I am in the data domain. Why do I need to learn LangChain in 2026? So in 2026, every other organization is looking for the data engineers who know LangChain because they want you to build their AI orchestration pipelines as well. So I know now you will say, hey, I also want to learn LangChain, but I do not have any kind of resources, any structure, any guide, nothing. Don't worry. That's why I have created this complete 5 hours long beginner friendly LangChain full course, which will literally hold your hand and will make you a pro LangChain developer by the end of this video. So first you will learn the fundamentals of LangChain, and as you follow along, you will learn much more complex areas such as parallel, conditional branches, Pydantic integration, tool calling, React agents, and much more. Not just this, by the end of this video, you will build your own SQL agent which will take the user input in the natural language and will automatically fetch the necessary data from the SQL database and will return the insights back to the user. Wow. So Ansh, Lamba, what are the prerequisites required for this video? Nothing, just basic Python is more than enough. The best part, everything is explained visually with cool graphics so that you can even understand the complex areas easily. Plus, this video is designed in the form of chapters so that you can just follow along in a structured guide, and all the notes and code examples are also provided with this video. In short, this is the one-stop solution for you to master LangChain in 2026. So bro, just take out your laptop, make your coffee, and just hit the subscribe button right now. And let's master LangChain in 2026 and let's crack the dream offer, dream job this year. I want to help you with that. Let's go.
So what's up, my fam? Happy Sunday, and this is the video that I wish I had when I was learning about these things. So without wasting your time, let me just tell you what is this video about. Obviously you have watched the thumbnail, obviously you have watched the introduction. So this video is all about LangChain. And if you are still thinking to learn about LangChain, and you know what, this is my personal analysis. If you are someone in the data domain or who is trying to enter into this domain, let me just tell you one thing. LangChain is that thing which is becoming more and more popular and which is in demand. So let's say you are applying for a position, let's say data engineering position or any position like in the data domain. Okay. Now there are obviously hundreds or even thousands of applicants applying for the same position. But if you add these kinds of frameworks, especially LangChain, because LangChain is one of the most mature agentic frameworks right now. Even if first of all, I know that LangChain is written in the job descriptions everywhere. Even if LangChain is not written in the job description, if someone is reading your resume and if you write that you have experience with LangChain, that will add a cherry on the top of the cake. Make sense? So that means LangChain is a necessary stuff that you have to learn. And let me just tell you one thing, which is a good news for you. LangChain is not just for like data scientists or machine learning engineers. It has nothing to do with all those domains. And I know why you didn't learn this technology, because you were like thinking the same. You were still thinking like, okay, this technology is all about machine learning, this technology is all about AI and all. No, this thing is for data engineers. And let me just tell you one more thing. LangChain is very similar for you can say it will look very similar to ETLs or those pipelines that data engineers build. And yes, this video is for everyone, but yes, if you are a data engineer, you should feel happy that you are learning LangChain because it is very easy for you to learn this. It is very similar to all of those tasks that you do on a daily basis. Simple. Okay, makes sense. So now what is required for this video, what we're gonna learn in this video? I know you have all of these questions so that you can decide if you want to continue with this video, because I know you are very important person and your time is like very important, I know that. But yes, let me just answer all of those questions. So first of all, in order to continue with this video, you should have basic Python understanding. Basic Python means you should know how to write functions in Python, especially some basic for loops and if conditions, and I would say some basic level understanding of OOPs such as classes and objects, and that's it. If you have this understanding, that means you are good to go. And now what we will be covering in this particular masterclass and how the, you can say, agenda will look like. So let me just show you that as well. So agenda of this particular video is very simple. I will expect you have zero knowledge. That means you are totally a beginner. Literally zero knowledge. Zero knowledge means zero knowledge in the AI world as well. Okay, forget about these things like technologies and all. Zero knowledge in the AI world as well. So you are totally a beginner who just knows basics of Python, and that's it. This video has dedicated chapters. This video has dedicated notebooks. This video has dedicated sessions that will teach you everything from scratch. And we're gonna literally cover from scratch. Let me just show you my notes that I have prepared for this particular video. And by the way, everything is available in my GitHub repo. So let me just show you that as well. So this is the GitHub repo for this video. Okay. And as you can see, there are like major 3 chapters, but in each chapter we have so many notebooks. If you just open that, you will see like 1, 2, 3. And then chapter 2, we have these things. And then chapter 3, we have these things. And yes, we'll be just building so much of stuff here. And yes, as I just mentioned in the introduction as well, you will be building an autonomous SQL agent as well on your own from scratch. And regarding notes, if you just click here, I have just put my live illustration notes that I have just used here, and everything will be illustrated and demonstrated live, but these are the notes that you can just refer, and you will literally see everything, like everything is written in detail. So all the notes are provided here, and we're going to just cover everything in detail. Makes sense? So everything is there for you. You just need to actually sit back and relax and just you should enjoy this video. And as I just said, everything will be covered from scratch, so no prerequisites, just basic Python and agenda chapters. As you can see that we are just covering every single thing which is connected to Langchain. So by the end of this video, you will become a Langchain developer. That means you will know like how to write code in Langchain, you will know how to build agents with Langchain, you will know how to connect dots with Langchain. You will be a confident Langchain developer. And then you will be able to build your projects on your own if you want to. And if you are, if let's say your organization is asking you to work on Langchain, you will be easily able to work on Langchain. I'm so sure about that. Simple. I will also tell you some about some resources that you can just use along with this video, and everything will be there in the video as well. Perfect. So I think now you have everything clear. Now you have the decision, and I know your decision. So let me just let me just quickly start this video, and I want to start this video, like today's session especially, with this positive vibe. So what is this? So basically these are my lovely family members who have recently cracked their job offers, and it can be their dream job role, dream job offer, dream job company, whatever, but they are literally happy, and I am also happy because they are happy, and this literally makes me feel proud. Okay, and congratulations to all of you. And congratulations to all of you. 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 So I'm literally happy. So this is the favorite part, like one of the favorite parts of my video, when I just say congratulations, because see, why are you learning? Why are you learning? There's a goal, right? So when you achieve it, you feel happy. So they have achieved their goals and they are happy. And when they are happy, I'm also happy. So you should also feel happy because you will also achieve your goals. Don't need to worry at all, because you are landed on this right channel. And if you haven't subscribed this channel yet, I don't know what are you thinking, because maybe you do not want to come into this list. If you want to, just hit the subscribe button right now, because I'm literally putting the content which is made for your success. Make sense? Okay. And let me just quickly show you my handles as well. So these are my handles. If you just want to follow me, if you just want to check my content, you can just go here and you can just learn more and more stuff as well. Okay, so let's quickly get started with this video, because I'm literally excited for this video, Langchain, because I love Langchain. Let me just show you everything and let's start learning. So let's start this masterclass with our cool heading. Agentic AI and frameworks, basically, because agentic AI are incomplete without the frameworks. And don't worry, we're gonna just understand everything from scratch. And when I say scratch, that means scratch. Okay, so agentic AI and frameworks. Okay, makes sense. So let's say we want to talk about this topic, agentic AI and frameworks. First of all, I specifically mentioned that agentic AI for data engineers, right? Why did I do that? Do you know what? The best professional out among, you can say, all of the professionals, I think data engineer is a person who already knows much about agentic AI. You will say no. I will say yes. Because agentic AI is just the new name for everything that we are doing right now, and data engineers are already well versed about that. So if and do you know what? Do you know the funny thing? Data engineers are the ones who are entering into the AI world after all of those professionals. That is the, I would say, a kind of pain point. Data engineers should be the first ones to enter into this particular domain, and they are the last ones. I don't know why, because they think like data engineers do not need to learn AI and it is something else, it is something out of the topic, it is for data science. I don't know, but that is why this channel is for you. This channel is just actually teaching you and providing you the knowledge which is required to be in that particular group which is always in demand, right? That is why, by the way, if you are not aware about this thing, if you just go on any job portal, if you just type AI data engineers, you will see that particular job postings as well. Because currently industry has also accepted the fact that AI engineering is incomplete without data engineering. So they have just started putting out those labels called AI data engineers. So I think it is the high time and the best time to learn. I wouldn't say best time, it is the high time when you will learn about agentic AI and all. So let's start this particular conversation. So I told you that I do not expect any kind of knowledge from you. So let's say you are this person who do not have any kind of knowledge about anything. Okay, let's say this is you and your name is, what is your name? Let's say Rahul. Do you know what, I just picked the random names and there was a real Rahul. He, I think, dropped a comment, hey, I feel so happy whenever you take my name. So shout out to Rahul, whoever the person is. Okay, so let's say he is Rahul. Okay, and this person doesn't even know anything about agentic AI frameworks, like why do we talk about these things. So first of all, do you even know the difference between AI agent and agentic AI? Do you even know the difference? No, I know this. So we will first of all discuss about this thing, because once you get this concept, only then you should learn anything else. Then you should learn the frameworks. You first need to understand the concept, like what is agentic AI and AI agent. Frameworks is not a very critical, or you can say very complex thing. Framework is just like a kind of module. It's just a kind of SDK. It's just a kind of package. We just call it as framework, right? The main thing is agentic AI. What is agentic AI? And in order to do that, we need to just understand this concept, agentic AI versus AI agent. So let's start with AI agent. Like what exactly is AI agent? Let's say this Rahul. Let's say this is Rahul. Okay, and this person needs to know everything about agentic AI and all. And you know what? This person first needs to understand the AI agents. Okay, so now when I just talk about AI agent, what is actually an AI agent? AI agent, what is this thing? Like why this term is so popular right now and everyone is talking about this thing? AI agent. AI agent is actually nothing about, you can say, is like nothing but a kind of framework in itself. Not the framework, let's not call it as framework, you will be confused. It is a kind of, let's say, real person. What is agent? Forget about AI. What is agent? If you just try to find out the word agent, agent is someone who performs a specific task. You would have seen, you can say, insurance agents, and then you can say customer care agents, and then you have flight agents. Like there are some agents. Like why do we use the word agent? This particular thing, this AI agent, is actually aligned towards a specific task. Okay, specific task, nothing fancy, this thing. So now we have added the keyword called AI. That means this agent is not the real person. Oh, okay, this agent is not the real person. This is AI performing the task of an agent. Okay, and in this case it will be, let's say, LLM, right? Okay, this will be LLM. When LLM, that means large language model, the entire AI industry is built on top of LLM right now. Makes sense, like large language models. So LLM, when able to perform the task of a real human, that will be called as an AI agent. But Ansh Lamba, can we say that all the LLMs are AI agents? No, I didn't say that. Hear me out. I said when LLM is able, when this LLM, let's say this is the LLM, okay, and this can be like any normal LLM, it can be chat GPT, it can be anything. Let's say this is your LLM, okay, this is your LLM. Wow. Let's say this is your LLM. Now this LLM can be anyone. OpenAI, let's take OpenAI because OpenAI is very popular. This is OpenAI LLM. This is simple LLM that just knows how to generate the text. Simple. Now, when we developers add some capabilities to this LLM in order to perform a specific task in order to achieve a specific goal, this LLM becomes AI agent. Okay, that is clear. But what are those specific tasks or specific capabilities that we add? Very good question. In short, in simple language, we add something called as tools. Okay, we add something called as tools. And now you will say, what kind of tools? I will say any tool, any kind of tool. So when we add this tools, okay, so we have provided it. Who we? This, let's say developer, Rahul. Rahul knows how to develop the tools, okay. Now these tools, when these tools are integrated with this LLM, okay, this thing and this thing, perfect. Now when we integrate these tools with this LLM, let me just write it for you, integrated, then it becomes this LLM simple. This is your entire definition, entire flow. And now this AI agent can perform this task, right? Now you will say, which task? I would say any task. Let's say reporting, data, email, anything. Let's say this is a task. Simple. Let's say this agent is a kind of customer assistant or basically customer service agent, which receives the emails and maybe filtering out the emails which are bad, which are right, and categorize it. It's a kind of task. Simple. That you would hire a real human for this task. Now you have AI agent for it. Now this developer builds these particular tools. This is the main thing to understand. This is the main thing. This developer built these tools. Okay, good. Now a very good question can be, like, you can ask like so many questions, but let's say you have asked this question, Ansh Lamba, yeah, why do we need to create tools and why LLMs? Because LLMs are so popular, everyone is talking about LLMs. LLMs are like so big, like they have raised billions of dollars. Why we need to create tools? Why we need to integrate tools? So very good question. Let me just tell you. Let's say you are using ChatGPT. Let's say, let me open ChatGPT in front of you. Okay, and I hope you know what is ChatGPT. If no, then very good. Slow claps. So let's say this is the ChatGPT, right? ChatGPT is nothing but a kind of wrapper. It's just a kind of front end that is built on top of LLM. Simple. Very good. Now, do you know what? When ChatGPT was launched in its initial days, if I ask something like this, my name is Ansh. Hello, bro. Let's say I write something like this. So ChatGPT would be able to generate this text and that's it. And when I was asking ChatGPT, hey, what's the temperature here in Canada? Right? If I hit enter, I will not hit enter right now because I need to explain this thing. In the earlier days, in the initial days, when I would be asking this question, ChatGPT would not be able to answer this question. Okay. Why? Because it doesn't have the capability to track the recent data. Because these LLMs, these large language models are trained on specific data sets, right? And they cannot train the data sets, like they cannot train the model on data sets on a daily basis. It is a very expensive task. So they do it, I think, once a year or twice a year. So they do not have like real time access. But you know what? When I hit enter now, just wait and watch. Canada is huge. Oh, it is very smart. Let's say temperature in Calgary. I'm not in Calgary, by the way, but yeah, let's say in Calgary. So now see, did you see? I know it's cold, minus 14 degrees centigrade. Yeah. So now the thing is how it is able to just get the right temperature, and it is actually minus 14 degree, minus 15 degree. I know this. Okay. Because here in my city, it is 11 degree. So yeah. Alberta is like the coldest, not coldest, but yeah, one of the coldest. So now I know that the temperature is minus 14 degrees centigrade. How it is able to track that? Now you will say, because LLMs are becoming smart. Not at all. Not at all. Now do you know what happened? This ChatGPT team built tools. Okay. This ChatGPT team built tools and they integrated those tools with this LLM, original LLM. It can be, let's say, GPT-5, GPT-4, any LLM model. They build these tools, and this tool can be, let's say, getting the weather information. And did you notice when we just hit that particular question, it showed that thing called searching the web. What is that thing? That is a tool call. Okay, so we build these tools on our own. These are nothing but the functions, and then we integrate these things to the LLM, and then this becomes an AI agent. Like, obviously we will be just doing so much of stuff to make it as an agent, to make it autonomous as much as we can. But this is the backbone of AI agent, LLM with tools. That's it. Because can you think of an agent which doesn't have any capability? So let's say we are hiring a real person, right? And person needs to write email, read email, and do so many stuff. So that agent, that human also needs some access, needs an email address, all those things, right? So it needs those capabilities. Same thing we will provide to this LLM, and then it will become an AI agent. This is the definition of AI agent. Okay. Now what is the difference between AI agent and agentic AI? Because this is clear. So always remember this thing. This is a kind of formula you can say, or just a thing, you can say way to remember it. So AI agent is built to fulfill a specific task. Okay, is built to fulfill a specific task. Let's say you are hiring an AI agent, basically building an AI agent. You are hiring a person, same thing. So you are getting an AI agent for this task. Let's say now this email task is done. Now you need to add an agent in your team who will do the marketing. Like, person is reading the emails, categorizing it, and that's it. Now this particular agent needs to talk to another agent who is a marketing agent, who will do the marketing stuff, who will run ads on social platforms. Make sense? And then that marketing agent needs to talk to, let's say, business agent, because it needs to communicate with the business team or finance team. Hey, how much money do we have to run ads? Hey, how much money do we need to spend this month? Maybe, right? So when we need to enable the communication between the agents, that becomes agentic AI. That means orchestration of AI agents. When we have multiple AI agents. And do you know what? The fun part. Agentic AI is always aligned towards fulfilling the goal. Now we'll say, Ansh, Lamba, AI agent is also inclined towards fulfilling a goal. The difference is AI agent is only fulfilling the sub goal, basically the task. But agentic AI is fulfilling the entire, you can say, goal, or you can say bigger project. So let's say you have a kind of social media managing company, and you have those AI agents built in specific areas, and that will be called as agentic AI. I hope it makes sense. Now let's relate this analogy to our data engineering. Let's say you are a developer, okay, and you have built some tools to run the Spark notebook, let's say Spark job in PySpark, right? If you do not know about PySpark, basically PySpark is the framework that we use to process big data, right? So you have built this AI agent to run the task, and task is running Spark, right? Running Spark job. Perfect. This is the task. Now this is agent 1, right? As we just mentioned, this is agent 1. Okay, this is agent 1. And let me remove this Rahul. This is very obvious now because they have the tools. So this is only and only agent 1. Makes sense. Perfect. Agent 1. Now do you know what? Before running this job, you obviously need to configure the Spark cluster size, like what cluster do we need. So actually this agent needs to communicate with another agent, right? Let's say this agent, or you can say it can be like to and fro communication as well. So it's not a big deal. So let's say this is another agent, and what this agent does, this agent configure the Spark cluster size. That what should be the cluster size on the basis of the data, what should be the, you can say, cores, number of cores, what should be the memory we should allocate to our jobs. Like it will give you the exact or ideal cluster size, and then you can just run your job. Before that you do not need to run the job. So we'll edit the task and we can say we are simply, let's say, talking about clusters, basically these servers. Makes sense. Make sense? Okay. So now the task is to give us the right server size, basically the right cluster size, and then we need to talk to each other. So now this framework will be called as agentic framework. Why? Because they are communicating with each other, and there's an orchestration. This is a very simple, you can say, a kind of orchestration where we just have like two people talking to each other. In the real world, we build the complex workflows where we have, let's say, 10 to 20 agents talking to each other. And the main thing is it is not linear. What do I mean? It can be branched out to too many things, right? Let me just show you. So let's say this is agent 1. Okay. This is agent 1, and this agent 1 can be connected to this one. Okay. Let me just make it small. So let's say like this, because I want to just show you the complex one. So that is why I'm just zooming it out. So do not need to worry. Okay. So let's say this is agent 1. This is connected to this one. And let's use this one. Perfect. So this is agent 2. And then let's say this will be connected to this agent. Can be. It's not a big deal. Right? Let's say like this. And then we have, let's say, 2 agents. Let's say like this. Let's say like this. Wow. Can we have these complex workflows? Obviously, we have it. So let's say this is the thing, right? And then we have, let's say, the final node, or basically the agent like this. So this is a complex agentic workflow. Let's say we have a conditional here that we can use. Perfect. So let's say this is the complex workflow. This is agentic AI. Now I hope that you have the clear understanding of agentic AI. Like what is agentic AI and what is AI agent? I hope so. This is also agentic AI, by the way, but this is a very simple one. But obviously this was required to make you understand the concepts, right? You can say agentic AI here, like here. And don't worry, I'll just provide all of these nodes in my repo, GitHub repo, so that you can just enjoy it. Agentic AI, I can simply say simple. And then we have complex as well. Here, let's write complex. Make sense? Perfect. So now if you have this clear, now you can just learn any framework, because see, now let's go back to our main agenda, agentic AI and frameworks. So now we know the difference of agentic AI and AI agents, obviously. And now you also know why agentic AI is becoming more and more popular, because we do not create just one AI agent and that's it. We need the entire flow. Now just tell me one thing, come here. If I just show you this agentic AI, and not the simple one, complex one. Have you seen this kind of thing in your day-to-day activities? And I'm talking to you, data engineer. Have you seen this kind of thing? I'm not asking you to think about LLM. No. Just take about, like, I'm just talking about these things, these boxes. I'm not talking about the stuff that is built inside this, just the nodes. Have you seen this? You will say, yeah, we have seen this in our pipelines. Exactly. That's what I'm trying to tell you, that we are actually building the pipelines and we are calling it as agentic AI. Now, yes, I'm not saying that it is not agentic AI. It is agentic AI. Why? Because we have AI workflows, basically AI activities within each node. But on the bigger picture side, this is just a pipeline. That's it. This is just a DAG, directed acyclic graph, that we build in our day-to-day activities. Make sense? So I hope now you are very much clear, and now you should know why data engineers need to lead this industry, and they are not leading the industry right now because they are too late and they are not actually learning AI, because this is the right time, high time to learn it. And don't worry, I will just make it understand everything. Okay, perfect. So this is the whole concept. And now let's talk about the frameworks quickly. Framework is not a very kind of complex thing. Framework is nothing but just a word that we use to portray something about, you can say, a module. Let's say I'm building a Python package, right? I have so many classes, I have so many functions, I have so many variables and blah, 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 blah. When I package them together, when it is ready to be reusable by anyone, it will be called as framework. Simple. If you just want to understand it. Okay. And if you just want to learn the definition of framework, go to Wikipedia and learn it. This is the understanding of framework, right? So the thing is, now, in order to build all of these things, obviously we can use our traditional Python language or any programming language. It's not a big deal. But in order to integrate with AI models, those LLM tool calling capabilities, all those things, we need to write our own package, right? Every time. Let's say if I'm just trying to build this particular logic, I know that I will be just reusing my code again and again. So let's build a package. So I will build my package. You will say the same thing. You will build your own package. Then third person will say, the person will build his own package. So now we have some solutions in the industry. Very popular ones are like Langchain. Okay. We have 1 to 2 very popular more. We have Llama Index. We have, I think, there's 1 to 2 more. Like, there are so many, but these are the popular and trusted ones that you should use. So Langchain is the most popular one right now that everyone is talking about, because it is open source. Plus, it is the most mature, I would say, framework. Plus, it is well integrated with all of the tools and technologies. Wow, this is amazing. So now let's talk about the Langchain. Now, what is Langchain? Langchain under the hood, I would say. Langchain under the hood. Okay. Langchain. I know the name is funny, but it is really, really cool. I still remember, like, when I was learning Langchain, I would say years back, it was like really, really cool and it was really new. And after that, we have got so many new things. But yeah, let's talk about Langchain, because Langchain was the early mover of the AI agentic, or basically you can say agentic AI and AI agents industry. Yeah, stay hydrated even if it is cold. So Langchain under the hood. Now, what is Langchain? Now let's talk about Langchain. So let's say you have something within your code, right? You want to build this particular thing. If you are a data engineer, you would have built something similar to this using your Python functions. You would have built it, right? It's not a big deal, because you are a data engineer, you are a data professional, you know already Python, right? Let's say you build this. Okay. Where is Rahul? Let's bring that Rahul. Let's say this Rahul. I'm making Rahul famous, right? So now we need to build a framework. Okay. I need to build the agentic AI solution, right? And you know what we need to build. And let me just bring this thing as well. Like, it will make more sense. Let's say I want to build this, right? Let's say we want to build this. Our goal is this one. Build this Rahul. So now this Rahul can build this entire thing. It's not a big deal for Rahul, because Rahul is a pro coder. Even not a pro coder, but he can build this using something called as, let's say, Python, right? Because Python is like amazing language. I love Python, and you should also love Python if you're a data engineer. So let's say you are building this thing, right? Simple. Perfect. So this Rahul can build this thing using Python. Okay. Makes sense. Okay, using Python. But now what will happen? What will happen? All of these code cells, all of these LLM tool calls, integration with the tools, and then just making it as an AI agent and then orchestrating it, it will take a lot of time, right? Everything is manual. That means everything is manual. That means Rahul needs to build all the classes. Now you will say, bro, why Rahul needs to build the classes? He will simply write the code because Rahul is working in an organization, right? And in that organization, there are lots of developers who are working. So in order to use that code, we need to build the classes, right? And I hope that you have some basic understanding of Python, like Python class, Python object. If not, bro, just go and just learn Python as soon as possible. And if you want to learn from me, if you want to learn Python from me, I have a dedicated Python course on my channel, and you can just simply search on YouTube, Ansh Lamba Python full course, and you will get the Python full course, and just make your Python skills or take your Python skills through the roof, because it is really important. So Rahul needs to build all the classes from scratch, right? Now I have a solution, or Rahul can use a framework. Rahul can use the agentic framework called Langchain. Make sense? Now in that particular framework, all the classes are built. Obviously, there's not like very specific use cases as per your organization. Obviously, you need to make so many changes, like so many tweaks, so many things, but it is very much efficient. Why? Because all the test cases, all the error handling, all of those things, boilerplate code, everything is gone. It will save us a lot of time. So Rahul will take this approach. Okay, Rahul will take this approach because Rahul is smart. So now Langchain is what Langchain is doing. So Langchain has built the Python classes for your agentic solutions that you can use anytime, or you can say that you can use and modify as per your use cases. Simple. This is Langchain under the hood. Nothing special. Nothing special. It is not magic. It is not actually no magic. You can write the exact code that Langchain has built. All the classes you can build on your own as well. But the good thing is Langchain has built all those classes for you so that you do not need to build everything from scratch again. And I hope it makes sense. It makes sense? To me, yes. Okay, so this is Langchain under the hood. So that means we are simply trying to learn Langchain from the Python point of view. There are like TypeScript or JavaScript support as well, but we are simply learning from Python point of view. Make sense? So let's help Rahul to build all of these things. And we know that Rahul doesn't know anything about Langchain because Rahul is new to Langchain. So we have a cool documentation about Langchain, and let me just bring that Langchain documentation. And this is the official documentation for Langchain that they keep on updating. And see, Python and TypeScript. So we have both capabilities. I will simply say Langchain Python, and this is the documentation of it. See, we have everything here. We have installation, quick start, change log, and blah, blah, blah. And then we have agents, very long documentation, very, very detailed documentation. And I love it, to be honest. And you can also go and check it out. But yes, initially Rahul wants quick overview, quick tutorial so that Rahul can start building using Langchain, and sideways Rahul can also explore the documentation. But Rahul wants some guidance, right? Some structured approach, because obviously when I was also learning Langchain, instead of directly going to the documentation, I also was studying through so many sources like books, playlist, courses, and then blogs, and then documentation, like everything, because I I will not say like there was no structured learning available or video available. I just wanted to learn on my own, like how things are working. And then I realized, let me just pass on this knowledge of all the sources. It is like a condensed form of knowledge, which is, you can say, the integration or condensed, curated knowledge of so many sources like blogs, courses, videos, documentation. So this is like one-stop solution for you to master Langchain, and literally master. Let me be very honest, because you will be able to just build anything using Langchain after this. Okay, so let me just start taking you to the practical lab session, because enough concept, enough thing is built, and we will be just learning so many things in the meantime as we go along with this video. Okay, and I will just provide this notes as well. Everything will be available, so do not need to worry writing down and all. If you want to write it down, it's good, but I will just provide it as well. Okay, so let's see how we can just get started with Langchain. Okay, let's see. So now let's talk about the prerequisites, not from the skill wise, because it is like very basic and very beginner friendly. You just need like basic Python knowledge and that's it. I'm talking about the system requirements. So you need, first of all, code editor, or basically IDE. It can be VS Code, it can be anti-gravity if you're using anti-gravity, which is launched by Google. There are so many code editors, you can use whatever you want. Okay, and we would need Python as well. So let's say system requirements, not system, I would say softwares we will be using. Simple. So we will be using some cool softwares. Cool softwares. So softwares will be, first of all, you need VS Code or anyone. Like if you like VS Code, I love VS Code. I love so many new AI code editors as well, because I keep on playing with so many code editors. So I just keep switching. Okay, you can also try a lot of code editors. And then we will be needing Python. So if you do not have Python installed on your system, that I would assume that you should install. Okay, and you would need one more thing, Git. Now why Git? Because let's say we are building something and you need to push that code in your repo, you would need Git, right? So if you do not have these things available in your laptop, first of all, slow claps and very well done. Tap your back. Very good developer you are. So you can just download all of these things. First of all, just go to any browser, search VS Code download, and this is the Visual Code download, and you should download it. Okay, this one, or this one. Then once you have this, you can download Python and python.org, or you can simply say Python download, just to directly land on that page. Perfect. So here you can simply download Python install manager. It will download the latest one, which is 3.14. And here you can see all the active Python releases. By the way, this is cool. Like I was not expecting this. So currently most of the people are using 3.12, most of the people. And you can see that this has a lifespan of almost like it has security around 2028. So that is fine. I am also using 3.13. But currently it is under bug fix. So there are so many things that are breaking or that can break. So that is not a very good time period to try this. And for 3.14, it is totally new. So I will just simply recommend you to download 3.12. And in order to download this, you can just go here and you will see all of these packages installed. So you will see it here, no installers. You can just go specifically on, wait, release schedule, not this one. Yeah, you can just search it here. So you can just scroll it here and it should be 3.12 something, maybe 3.1212. It also doesn't have any kind of installers. 3.12.3. Does it have any kind of installers? Like you can just check if you have, yeah, it has installers. So if, yeah, Windows 64 or Mac, whatever. So you should download 3.12 Python because it is the most stable version available right now. 3.13 is also good, but 3.12 is better. Then you need to download Git. Simply say git install and click here. And here you can just choose your, you can say provider, and you will simply download it from here, from Mac, from Linux, and whatever. Download these three things and let's get started. So for this particular video, I will be using Anti-Gravity. Anti-Gravity is a new code editor. If you don't know about it, it is by Google and they have amazing free features available. So if I go here, anti-gravity IDE, see, this is the one. You can download this on your system and you will love it, okay? Because this is like agentic code editor that you can just use within your code base, and it is amazing, okay? So let's get started with our setup on the system, okay? Let's see. So welcome to my anti-gravity code editor, and as you can see, this is the interface. Very straightforward, very simple, very similar to VS Code, and obviously everyone loves VS Code, so it is also having the same UI, everything. Maybe it is built on top of VS Code because VS Code is open source. So here you will see this is the agentic area, by the way. You can collapse it by clicking here, and we'll be using throughout the project, throughout the tutorial, don't worry. And this is the folder that I have created, Langchain tutorial. You can also create this folder, and as you can see, this tutorial is empty. This tutorial this tutorial is not empty. This tutorial folder is empty, okay? So as you can see, you can also create it. Make sense? And how to do that? I think you should know how to create a folder, right? And then you can just open it, go to file, click on open folder, and then open that empty folder. Simple. It will just pop up like this. Do not worry about these things because this can be different in your case, because I have downloaded some extensions, let's say DBT, and there are so many extensions that I downloaded, so just ignore. So I would say it is anti-gravity, and this is not very complex to explain you. So this is our you can say code editor that we are trying to use. Perfect. So without wasting any time, let me just initiate my particular project. So I will open one terminal. In order to open a terminal in anti-gravity, you can click here in the terminal and new terminal, or I can use the shortcut Control Shift and backtick. Okay, choice is yours. So this is my terminal. So what is the first thing we do whenever we just initiate anything, especially for Python? The answer is creating the virtual environment. Common sense. So now let's create the virtual environment, and you know what? We will not be using pip. Ansh, Lamba, we have to use pip. No, we do not have to. We have something called as UV. If you do not know about UV, I think you should know about UV, because UV is the modern Python package manager, and we can just do everything with UV that we used to do with pip. How you can also get started with it? In just one line, you simply need to say pip install UV and hit enter. In my case, I have already downloaded it, so it will simply say requirement already satisfied. In your case, it will say like it is downloaded. Okay, once you have pip like UV installed in your system, then you can just start using UV, and it is so convenient. I will just show you. In order to initiate a project and creating the virtual environment, you do not need to write multiple commands. You will simply say UV init and hit enter. Perfect. It has created the entire project for me. .get, getignore, Python version, main.py, pyproject.toml, readme.md. Make sense? Very good. Now, in this Python version, if in your system you already have, let's say 3.13 installed, or let's say 3.11 installed, and you want to use 3.12 just for this tutorial, you can simply write it here. As I have written 3.12, like I have not written it, UV has written it for me, but you can just change it here. Okay. And what to do after that? Hold on. I will just tell you. Just change it here for now. Just write 3.12. Simple. Good. Now, in order to initiate the virtual environment, we do not need to write any special command. By the way, we have a command in UV called, let's say UV then .vnv, but I can also say UV sync. This command is a very special command, and the combination of commands, it will simply sync everything. If I have written 3.12, or even let's say if I write 3.11 or whatever version, it will take that Python version. It will create the virtual environment for me. Two things. And the third thing is whatever dependencies I have, it will install all of those dependencies. But Ansh, Lamba, do you know what? You do not even have requirements.txt. How will you install the dependencies? When we work with UV, we do not need to worry about requirements.txt because we work with pyproject.toml. So if you open this file, you will see dependencies list. So whatever package you write here, automatically it will add all of those dependencies. Okay. So first of all, let me just write UV sync and hit enter. Perfect. So now you can see that it has created .vnv. And by the way, if you are not seeing this .git folder, it is fine because it is hidden by default. I have enabled it because I just like seeing it here, but it has no use because we should not touch this .git folder because it is a database that it uses under the hood to manage our Git. Okay, you should not touch it and open it and make some changes, otherwise your code base will be broken, right? So yeah, but I have just put it here. So you do not need to worry if you do not see .git. It has nothing to do with your Git. Okay, and if you just observe in the bottom side, I have the master branch as well. That means it has also run the command called git init automatically in the backend. When I write uv init, it runs git init as well. So let me just define my branch quickly. Let me just rename my branch and I will say git branch -m main. If you do not have git fundamentals clear, do not worry, just follow this command. It renames my branch. So now as you can see, my branch name is main. Let's create the initial commit. I will say git then add dot, okay, and then git commit -m initial commit. Basically this is the initial commit that we are creating for this branch so that it will be registered. Hit enter and that's it. Now we will not be touching this main branch, don't worry. Make sense? If you do not know about git, don't worry, just copy these two commands and that's it. Do not behave like oh what is this command. So now we first of all need to install the Langchain library in Python. Okay, and how we can just do that? Simply say uv add, same way you say pip install, here we say uv add Langchain. Okay, just hit enter. It will add all of these libraries and dependencies automatically. If I open my toml file, I will see all of these things are written here. See, Langchain 1.2.0. Wow. Make sense? Good. So I have downloaded Langchain library. Okay. And I can also verify it. If I just go to .when, if I go to lib, I should see Langchain. See, I have all of the things installed in my virtual environment. Makes sense. Now let me just enable the virtual environment. .when scripts activate. VS Code automatically enables your virtual environment. That is a plus sign, but here we have to do it manually. So our virtual environment is enabled. That is a good thing. Okay. So yeah, makes sense. So now what we're gonna do, we will be creating chapters. Okay. Let me create our first chapter and let me just name it as chapter 1. Yeah, simply chapter 1. So in this chapter 1, we will be creating our notebooks, like notebook 1, notebook 2, notebook 3, like this. So in this folder, let me just create my first notebook and let me just name it as basics.ipynb. If you're not familiar with ipynb, this is basically the IPy kernel. Okay, IPy kernel notebook format, which is very similar to Jupyter notebook. Simple. If you do not know about Jupyter notebook, I don't know what you are doing. Okay, you should know about Jupyter notebook, bro. You are a data professional. So this has created this particular ipynb. In your case, it will also ask you to download or install IPy kernel. Simply say okay and it will install it. And first of all, you need to click on select kernel and select the kernel Python environments and pick your virtual environment. Perfect. Because only then you will be able to use the Langchain libraries. Perfect. Now, first thing that you need to do. Okay. What is that particular first thing? Now you have all of these things ready. Now do you know what you need to do? You need to go to Openai. Do we have Openai thing? Let's use this one. So now you need to go to Openai and Openai. Why? Because now you need to create a kind of API key because you'll be using the hosted models. High quality models. We will not be using open source models because there are so many things that only hosted models can do and that you need to learn as well. And that is why we will be just covering everything with OpenAI models, right? So how you can just go to OpenAI, simply go to browser and search OpenAI API. Simple. So this is API. This is not ChatGPT, by the way. This is OpenAI official API platform. Okay. Click here. and here you will be landing on this page. Click on login and you can click here and do not select ChatGPT. Select API platform. Make sense? Select API platform. Because once you land on this API platform, then you also need to create the API key. Make sense? API key. Okay, let me just show you my account. So this is my API platform account. Okay. So in your case, you will land on the home page. Okay. And then you simply need to click on settings and then you need to click on API keys. Then you will land on this page and here you can create your new secret key. Okay. Click on plus create new secret key and I can also create it right now and I will just show you. Okay. Not in front of you, you will use my secret key. Obviously I will just revoke it, I'm just kidding. So yeah, you can just simply say create new secret key. So this will create a secret key like this, sk hyphen something something something. You need to note it down somewhere else because it will be hidden after that. Okay. Once you have the secret key ready, once you have everything, you need to go to billing. Okay. And you need to add some amount in your account. It can be very minimal. It can be $5 and yeah, literally $5. You can just add $5 in your account. What it will do, it will just use that amount to make the API calls, because whatever you can say API call you are making, it will use some amount, right? Do not worry, it will not charge you directly from the billing that you are using. It will simply deduct the amount from the amount that you have added in your account. It is a kind of, you can say, recharge that you do in your mobile phone, or you used to do before, because nowadays we have just bills. But before, remember, we used to do the 10 rupees, 20 rupees, 50 rupees recharge coupon. We used to scratch the number, we need to dial it, and then it gets added into your system, into your mobile system, right? So it is similar to that. And you will say, hey, is it enough? $5 are enough? I would say more than enough, because if you will be using that particular $5 for making API calls to LLMs, I would say it will hardly charge 0.00 something. I will just show you the, you can say, model cost, model pricing. It is very, very minimal. So you can just feel very, very good that if you add $5, it will be like more than enough. And not just like for this video, you can even practice so much of things with that $5. And I'm not kidding. I am not kidding. Like $5 is like more than enough for you. Let me be honest. Okay. And obviously it depends like which model are you using, but for most of the models, it is like more than enough. Let me just show you the pricing quickly. If I go to OpenAI models pricing, so API pricing, and here we have GPT 5.2, which is the most advanced version right now. So it is having $1.7 per 1 million tokens, and 1 million tokens is a big deal, bro. And this is the most curated model. And then we have GPT 5 mini, which is the latest one, but a mini model. It is very cheap. So just 25 cents per 1 million tokens. And can you imagine, per 1 million tokens, just $0.25. So $5 is like more than enough, And we can use, let's say, GPT 5 mini. We will be using this one, GPT 5 mini. Okay, the cheap model, but it has like all the features available that we want to use. So you need to do this homework. Okay, once you have that homework ready, then we are good to go. Okay, so now once we have done that homework, now what we need to do, we will simply go to our anti-gravity or your favorite, you can say, code editor, create one file called .env, and then just add your API key. And you need to create a variable called OpenAI API key equals whatever your key is, whatever. Obviously, I will also not show you, but you need to put that value. Why it is showing like this? SK, or this is like demo value that it is showing. SK something, blah, 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 blah. So it will be like looking like this, because this is like kind of demo value that it generates, like SK, because OpenAI API key always starts with SK. So you need to put this value in your particular case. Make sense? Because we'll be using this environment variable. Okay, perfect. So here is my API key. Okay, and this is like incomplete because I am not sliding towards right, and I will just revoke it after this video. So this way you need to put your API key here. Why? Because we do not expose our API key in our code. It is not a best practice. We should always create an environment for our API key. Make sense? Okay, very good. So let me just close it, and we have .env in the main code base, in the root directory, not inside chapter 1. It should be at the root directory level. Okay, makes sense. And we can even hide it, or basically exclude it from our code base. Go to git ignore and simply say .env. What will happen? The Advantage is now it is not the part of, you can say, your code base, your development. Now it will not be published whenever you will be pushing this code to GitHub. Okay, good. These are the best practices that I'm just telling you in the meantime, because if I'm teaching you something, it's my responsibility that covers everything, including best practices. So first chapter is basics. Now what we are just trying to learn in the basics. Let me just show you something and you will be like, oh, okay, that's how it is done. Okay. So now let me just say Markdown. Basically, this is the Markdown cell where we can just create headings. And don't worry, all of these notebooks will be available in my GitHub repo just for your notes. But I want you to write everything code by code. You can say character by character, so that you can also learn. You can also build. Okay, it's not like, okay, you will write everything, we will simply read it. No, you are a coder, you are a programmer, you are a developer. Make sense? So let me say LLM call. Let's simply try to build this simple LLM call. Okay, so now what are we trying to do? We want to make an LLM call that ChatGPT makes behind the scenes, right? And we'll be using LangChain for that. Now the thing is, we can make this LLM call very easily without LangChain as well. It's not a big deal. Let me just show you how we can just use or make API call to Openai. Okay, and how we can just use LangChain, and why do we need to use LangChain? So let's say, let's go to documentation, and I will simply say, let me close so many tabs, bro. Okay. Perfect. So now let's say I want to make an API call, Openai API, Python. Okay, I want to see the API reference. Perfect. Because they keep on changing the code, not frequently, but yeah. So this is, where is that? Python. Earlier they used to have one switch between the languages, introduction. It will be somewhere here, but let me just check it. OpenAI, or maybe I can just use this LLM. This is good. So this is the code that I use. If I just copy it, and if I go to anti-gravity, if I write it here, and obviously I need to pick code, right? So I'm writing import OS, right? And then from OpenAI, import OpenAI. And this is the exact thing that we are doing. In case you do not have this OpenAI installed, you can simply say uv add, and first of all activate the environment. So uv add OpenAI. Perfect. Now we have OpenAI library installed. Make sense? So now what we are doing, very simple Python function, not even a function, I would say, I'm simply creating a client. So this is OS module, simple. And why OS module? Because we want to get this environment variable. As you can see, I am using the client using OpenAI function, which is built by OpenAI, not by me. I am passing this API key because without that we cannot work, right? Because it needs to identify who is making the API call, who is asking me to provide the answer. It's you, it's Rahul, right? Rahul is making the API call, so Rahul needs to provide that particular API key. And where is the API key stored? Now you can hard code the API key value here, but Ansh Lamba just told you it is not a best practice because you can just simply expose your API key. So we store all the secret, or you can say secret keys, in the environment.env, and then we just pull it like this. os.environ. os.environ returns a dictionary of all the environment variables with value as its value. And then we use .get function. You can also use your simple square bracket notation as well if you want to, like this, it works. But .get is like the standard to pull the you can say environment file, so that is fine. Then we are simply creating a kind of variable chat completion, client.chat.completion.create, okay, and then we are simply writing the messages. Now we are saying, hey, we want to send a message to the LLM, which is the LLM model we are using. I will simply override it, don't worry. And the role is user. That means I am the user who is sending the message. Content is, say this is a test. No, I don't want to say this. I want to say, bro, tell me a joke about, or let's say tell me a fun fact. Okay, tell me a fun fact. I want to know about a fun fact. Make sense? I want to ask this. Okay. And I want to use model, which is GPT-5 mini. GPT-5 mini. Make sense? I want to use this particular model, GPT-5 mini. I can pick any model. I can pick 4.0, I can pick 4.1, I can pick 5.2. There are so many models. I want to pick this model, GPT-5 mini, right? And then I'm simply printing the content of the response. Simple. Let's try to run this. Let's see what happens. Install requires IPy kernel. I told you, yes, install it, because it asks you to install IPy kernel in your virtual environment. So now let's see what will happen. Do you know what will happen? It will generate the response that will be created by LLM. LLM means this language model, this large language model, GPT-5 mini. Okay, let's wait. Okay, see, this is the response. Bro, fun fact. Wombats poop in cube shaped piles. What? They used a stackable cubes to mark territory and communicate. Oh. Oh, bro. This is actually a fun fact. I still remember reading those fun facts written at the back or at the end of our classmates' notebook, which was the most premium notebooks. So yeah, it's good. So see, we have just got the response the same way we are getting from the chat GPT, like from here. See, same thing. I'm just simply writing the message here and I'm getting the message back. That's exactly ChatGPT has done. We are simply passing the message, they are simply generating the response, and we have done the same thing. We are passing the thing, we are getting the response, and we are simply building a kind of front end just to show the message. That's it. That's it. So that means you have built ChatGPT. Kind of. Kind of. Okay. Now you will say, Ansh Lamba, what is the problem? Like, we didn't even use Langchain. So now why do we need to use Langchain? Okay, let me just ask you a simple question. And let's say you are, let's say why Langchain, right? This is your question, right? So let's say Rahul, where is Rahul? Bring him here. Rahul. So let's say this Rahul is using OpenAI model, right? Let's say this Rahul is using OpenAI model. Let's say this is OpenAI. Okay. GPT 5.2, right? 5.2. GPT 5, let's say not 5.2, 5. Let's be honest, because we are using GPT 5. So we are using GPT 5, okay, to make the API calls. Okay. And we are able to do it very easily. Okay. And we have got the response. Okay, perfect. And I'm just doing my work. Now everything is running fine. And to make these API calls, I'm not using Langchain. I'm using the official Python SDK software development kit provided by the OpenAI model. Perfect. So I'm using OpenAI SDK. Perfect. Okay, just to make this API call. Now suddenly I realized that OpenAI models are very good to generate analysis, to generate reports, to generate research, whatever. But they are not very good in terms of, by the way, no offense to OpenAI models, I'm just talking it as like you can say hypothetical situation. And we all know that Anthropic, Claude models are very, very good in terms of coding. Everyone knows that, right? So let's say in my project, I want to use OpenAI, yes, but for specific tasks, I also want to use, let's say, special model called Anthropic, or let's say Claude. And if you do not know about Claude, you should know about Claude, bro, because Claude is very, very famous. Now, if I want to use Claude as well, what I will do? Same thing. I will make the API call and I will use Claude, or basically Anthropic SDK. I think Anthropic is a parent company, Claude is the product. Okay, makes sense. So I'll be using Claude SDK. Now let's say I want to include one more, you can say model. Let's say I want to use Gemini to generate images. Let's say I want to use Nano Banana Pro, whatever, right? Let's say I want to use this thing. Let's say this is Gemini, right? Let's say I want to use this. What will happen? You will say, same thing. We will simply write our code using SDK. Simple. Perfect. And which SDK you will be using? Obviously Google SDK. Perfect. Now just tell me one thing, bro. How many SDKs will you use? Let's say I want to use 10 more models. Oh, so what if I just tell you that you can use this model, GPT-5, okay? GPT-5, use this model, okay? You want to use Claude, okay, use it. Okay, you want to use Gemini, use it. And here, you have all the models, right? All the models, let's say 20 plus models, 30 plus models, whatever. Let's say all the models are here. Okay. Now if I say, Rahul, come here. Instead of writing so many different SDKs, because every SDK has its own syntax, every SDK has its, you can say, own code, whatever, right? So now this Rahul can use something called as Langchain. Okay. Now this Rahul can use, let's say, something called as Langchain. Now this Langchain, what will do? This Langchain is a kind of wrapper. This is connected to it. This is connecting, all the models are connected to it. So Langchain will handle all of the SDKs, and we just want to use or need to use Langchain SDK. Just tell me one thing. Is it better to use just one SDK to use all the other models, or is it better to use different SDKs? Obviously this is better. Obviously this is better. So we do the same thing. We just use this thing as Langchain. We do not use different SDKs. When we didn't have agentic frameworks, let's say Langchain, LangGraph, all those things, we used to use different SDKs, and it was a chaos. And then now we have only single SDK, which is Langchain, and life is sorted. We do not need to use different SDKs. We can access all the models. Wow, that is really cool. Yes. So now instead of using this, I will use Langchain. So how we can just do this? For that, I need to install one more library. It's called Langchain Openai. So I will say UV add. Let me just open this one. Okay, perfect. UV add. Make sure you have this on. You have this virtual environment turned on, and I have already shown you how you can just turn on .vnv scripts activate. That's it. Okay. So UV add Langchain Openai. Add this. Now, what it will do? It will simply call it. So I will simply say from Langchain Openai, and I want to import a function called chat OpenAI. Okay, chat OpenAI. Okay, now I'll simply say LLM OpenAI equals chat OpenAI model equals GPT-5 mini. GPT-5 mini, that's it. And temperature equals 0. Now what is this temperature? If you do not know, temperature is basically the creativity of a model. If you set it to 0, that means model will not be creative. Model will simply generate the answer with the best possibility. But if you set, let's say 0.9, 0.8, 0.7, model will just play around the output, and it can just generate some random output as well. It depends like what is your use case. If you are just generating very serious and you do not need to play around with the output, you should only say temperature equals to 0. So LLM OpenAI equals chat OpenAI. Okay, and then you can simply say if you just want to ask something from this model, you will simply say LLM OpenAI dot invoke, and then I will say, bro, tell me a fun fact. Make sense? And this will generate me the output. And do you know what? This time I will not curate the output. I will just show the real and raw output, how it generates the output. Let me just show you. So let's wait. Perfect. This is the output. We always get the output in the form of AI message. There are 3 different types of messages: AI message, system message, and human message. We will just talk about messages as well very soon. But this is the raw output. But we can just obviously curate it. We can simply say dot content, and that we do every time. But this is the raw message. AI message, that means it is sent by AI. And this is the fun fact. Let's read it. Bananas are technically berries, but strawberries aren't. Wow. Botanically, a berry comes from a single. Oh, okay. While strawberries are an aggregated accessory fruit made of. Wow, this is actually a fun fact. Okay, now if I just run this, now I can simply get the content, only the content, not the raw output. So this is a very basic use case of Langchain API. Now what is the advantage of it? Now let's say I want to use Anthropic model. I will simply say from Langchain Anthropic import chat Anthropic, and I can make LLM Anthropic as well. Simple, like this. And I can use Claude 3.35 Sonnet. By the way, we use 4.5 Sonnet. Yeah, but I will not use Anthropic because I do not want you to create multiple API keys, because for this you would also need to create an API key in the Anthropic platform. But I just want to show you the use case of it. Make sense? Okay, makes sense. There's another way to create this particular thing which is recently added. It is called init chat model. So you can simply say from Langchain dot models import init chat model, or I think from just models. Yeah, I think just maybe from Langchain, because they have recently added from Langchain. Let me just check the init chat model class. Init chat model Langchain. Oh, chat models, perfect. So we have chat models and import init chat model. Perfect. So in this init chat model, we do not even need to define, like if we are just trying to import OpenAI models, Anthropic models, we simply need to put the model name and that's it. I will simply say LLM OpenAI equals init chat model, and then model name, or let's say model equals GPT-5 mini. This is recently added. Okay, even if you use any function, it is fine, so not a big deal. And let me just invoke it. Let me say hello, how are you, and it will say I am doing well, thanks, how are you, how can I help you today. So it is just making all of these API calls using your API. Make sense? So these are the ways to make API calls, basically LLM calls. Simple? Good. Now let's talk about the messages, because we just saw the type of messages. Okay, now I want you to make aware about the messages that we can use within Langchain, or basically in the agentic framework that we use, because in the every agentic framework we use messages, and messages has a great role to play. Okay, so let me just bring it here. Let me just explain you the messages, like why messages is a big deal. Why? I would say you will know the reason why. So messages, if you want to communicate to anyone, let's say Rahul, where is Rahul? Yeah, come here, bro. Let's say this Rahul needs to communicate to anyone, right? Anyone, let's say this Rahul needs to communicate to any team, any human, anyone. Let's say this Rahul needs to talk to these users. Make sense? So obviously, in order to communicate to these people, this you can say two-way thing is very important. Make sense? Because this message, this Rahul's message is, you can say, Rahul's message, right? Let's say you are just hearing to a transcript of a call. By the way, you should not hear to someone else call transcription, but let's say you are hearing it. Okay, let's say you are just hearing the call transcription of your best friend, okay, with their whatever. Okay, you know what I mean. So let's say you are hearing to that transcription. So what you will hear? You will hear Rahul's message, and in return you will hear this person's message. Okay, let's make it as, let's say, purple. Let's say this person's message, or let's say user's message. Let's say this Rahul is listening to, or basically talking to, group of people. Okay, so I will simply say let's create one person. It will be fun. So let's say one user. Perfect. Okay. This Rahul is talking to who? Let's say Simran. Who is Simran? I don't know. Just a hypothetical situation and hypothetical person. So this Rahul's message and this message will be called as Simran's message. Right? By the way, why are you laughing? Two people are talking to each other. What's the big deal? So now let's say these two people are talking to each other. So now if I want to hear to this person, I will say Rahul's message and this is the content. Tuck, 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 tuck. This is Simran's message. Tuck, 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 tuck. So this is the communication, the way of communication between two people, right? We have like identity of each message, like who is delivering which message and who is receiving which message. Simple, nothing fancy. Very good. Now let's talk about the real stuff. Let's say this Rahul is talking to an AI. Okay, what? So let's say this Rahul is actually talking to AI. Okay. Now, like real AI, okay? So now let's say this Rahul is talking to AI. Makes sense? Now just tell me one thing. This Rahul's message is this, I know that, and this AI message will be this one. Simple. This is the AI message. Okay. That AI is generating, basically LLM is generating. Okay, makes sense. Okay, simple. So this is also done. So this Rahul's message will be called as user message in terms of technical language, because Rahul is a user. Okay, Rahul is a user. So this will be considered as user's message. Simple. Like, I know it is new, but it is not very much complex. This is user's message. Okay. This AI message is obviously like AI message. Simple. Now there's one more term. It is called system message. Now what is this system message? This can be confusing. Okay. Let me just take you to the previous example. Now let's say Simran. We need to set the tone for Simran. I know Simran is talking to Rahul. Okay. And Rahul is also your friend. Simran is also your friend. Okay. And now you need to tell Simran that you need to talk to Rahul, but you need to talk, you can say softly, or you do not need to say anything rude to him. So you are setting the tone. You are setting the environment, like how they should just talk to each other, right? So you are guiding Simran, like how you should talk to Rahul. I will say, talk nicely and be a little polite. Okay. This is the tone that I have set for the environment, for the conversation, for the responses. So now do you know what? All of Simran's responses will be polite and will be very nice towards Rahul. Same thing you can do it in LLM as well. You can tell LLM that, hey, talk nicely to me and be a little polite. Why does it matter? For example, let's say you are asking LLM to write an email to your friend. Email to a friend. Let's say you are living in 90s, you are writing the letter. So you are asking LLM to write an email to your friend. So obviously it should be a little polite. If you are just writing an email to your manager, it should be formal. So you need to set the tone. That environment is called system message, nothing else. System message. So this system message is your this thing. Simple. I hope you understood with the example. I am so sure. So this is the system message. Because see, I need to take examples so that you can understand it simple. So this is system message. So that means Only user message is in your control. AI message is in AI's control. System message is for LLM, but you control this because you set the tone. Okay, make sense? So this is all about the messages. This is like real world analogy, whatever you want to say. And this is the real use case of it. Now I hope you understood it with the help of example between Rahul and Simran. So now let's try to code it. Now Rahul, just focus on coding, forget about Simran, and now let's talk to LLM, right? Because see, now let's create a new notebook. This is like very basic notebook because I want to provide this particular masterclass in the form of structured chapters so that anyone can go to chapter 1, 2, 3. Within that we have topics, basics, and all those things. So it will be very handy. And let me just rename it. Let me just say 1 LLM call. Simple. Now let me create a new notebook. I will say second messages.ipynb. Perfect. So let me just talk about the messages. And you know the messages, like why do we need messages? Why do we use messages? So now let me just write the code. So in order to use the message, we have like a specific library that we need to install. It's called Langchain core. Langchain core. And by the way, I will be referring to this particular Langchain migration guide as well, because they have recently upgraded the Langchain to 1.0, and earlier we were using 0.3, 0.6. They just changed almost all the syntaxes, all the classes. I don't know why. I like, does that make any sense? If you want to add something, make new functions in the existing classes, why you need to change the classes names? You like what will you get to break the code bases of the people? Okay, so this is basically the guide. So the thing is, I am also exploring this particular new, you can say, version of Langchain. This is the older version, not older version. This was the, you can say, traditional way to use those particular classes. Simple. But this is, you can say, latest way to use the classes. It doesn't mean that you cannot use this method, but I am thinking like if I'm just teaching you something, so I should just use the, you can say, most recent and latest version. That's it. Okay. So currently I'm not seeing anything for messages, so we can use the messages as is. Okay, makes sense. Okay. Okay, we have a new thing, Langchain.agents. No, this is same. Message is the same. Okay, makes sense. Okay, so I'll be just switching between these particular things so that I will just provide you the latest code as well. By the way, you can use the older version as well. It is not old. It is just like, it is the previous classes that we used to work with. Okay. Nothing is there to make you worried. Okay. So let's say messages. So what I will do, I will simply add the library and I will say uv add, and it will be like Langchain core. Perfect. Langchain core. Did it use Langchain or Langchain core? Langchain. Where are the messages? Okay, Langchain.messages. We use Langchain core. Okay, now we can just use Langchain.messages as well. But yeah, that's fine. Because if it is outdated, we will see the error. Don't worry. So I'll simply say from Langchain code. Oh, we need to select the kernel. Perfect. From Langchain core.messages, we will import human message. And do you see all of these code completions? And do you know what? This is not Pylance. This is not something, an extension. This is called anti-gravity's agent mode, which is available for free. If you go to anti-gravity settings, you will see snooze button. This is for AI agent, right? So they are running the free AI models, okay? The pro models for you for free, because all these code completions are not free. If you use VS Code, you have to purchase it. It is not available for free. Anti-gravity has made it available for free, maybe for shorter period of time, because they have just recently launched anti-gravity. But yeah, if it is for free, you should just take the advantage of it. So it will be like human message, and then it will be, let's say, system message, and we want to import AI message. Perfect. And once we have all of these messages, I will start writing my messages. I will say my messages. Simple. My messages will be this. I want to say list. I will say human message. Okay. Human messages, and then I will say content equals, and whatever I want to say. I will say, bro, tell me a fun fact. Simple. But this time, I will not just send this particular message to LLM. I will also set the tone. Remember system message? And it is saying you are a helpful assistant, right? This is a tone. This is telling LLM that you are a helpful assistant. I will say you are a Gen Z assistant. Yeah, Gen Z assistant. Which, or let's say who always answers in a fun way. Let's say we want to just set the tone for LLM, right? Wow, can we do that? Yes, you can do that. So now what I will do, I will simply say LLM. Oh, we need to import the model as well. This one, remember, we just create the model like this. So I can also create the model first of all. Perfect. So we have the model ready. Now I will simply say LLM dot OpenAI dot invoke. Now I will pass the entire list of messages, system message, human message. Perfect. Now let's see what we get. I will say dot content. So now you will see that this LLM will try to answer in a fun way, in a Gen Z way, which will actually, you can say, impact the response. Obviously, because you are just setting the tone for that LLM. And this way you can ask LLM to behave like anyone. You can even say, hey, behave like, let's say this person, not like this person, obviously system should know about this thing. And why it is taking so long connecting to kernel.vnv? Yeah, like see, this is anti-gravity, this is new thing. So there can be so many bugs. So do not need to worry at all. So you can simply rerun it and you can just cancel it. And you can maybe refresh it. So let me just reopen this anti-gravity. Okay, let's see. Because see, that's why they just provide you these stuff for free in the beginning, so that you can just detect the, you can say, bugs and all. Could not register service work, blah blah blah. Open in text editor. Are you serious? Let me just open this open text editor. So I think something is broken in anti-gravity. That's why it is not able to open anything. IP, Y, and B could not initialize web view and blah blah blah. So if it happens with you, you do not need to worry at all. You can simply close everything and just refresh or basically terminate this particular application, anti-gravity, and just start it again. It will work after some time, because something is broken maybe on the IP kernel side and nothing is broken on in your code. Your code is running fine. And you can also switch to any other code editor, let's say VS Code, which is more stable. But yeah. So I have just restarted my application like completely by ending it or terminating it through the task manager. So now let's try to see, and it has detected our kernel this time. Very good. Slow claps. If anti-gravity you are watching this is a bug for you. Fix it. Call your development team. Okay. So now let me just invoke it, because we want to see the output. Perfect. Let's wait. And perfect. Now I got the response. Bro, fun fact. Same thing. Bananas are berries, but strawberries aren't. But this time, if you see the tone, it is also using, let's say, emojis or all those things that a Gen Z will say. Make sense? See, wild, right? So this is actually talking like a Gen Z. This is actually talking like a person who is a Gen Z, because you have set the tone. That way you can modify, not modify actually, you can direct the responses in a certain direction. Let's say you want to build an LLM who is a kind of comedian, who is a kind of, you can say, write posts about some laughter, or who generates a content about, you can say, around laughter. So you need to set the tone for it. You can simply say you are a comedian who talks about this thing. So you can set the tone. So now do you know what? When you just set this tone, whenever you will be just invoking this thing with this particular system message, with this system message, it will remember this thing. This is a very basic use case of system message. Okay. Now we have some built-in messages as well. Okay. What is built-in messages? Built-in messages, or I would say prompts, because this is a very basic thing, right? I'm simply writing human message and system message. This is a very standard way. This is like Openai style messages. Okay, because system message, human message is only available in Openai. If you want to use, let's say, any other model, it will not be like system message or human message, it will be something else. So for solving this problem, Langchain provides us something called as prompts. We have dedicated library for prompts. What does it mean? Basically, let's say I want to pass a prompt, because see, whatever I'm passing here is a prompt, right? This is a prompt. This is a prompt, right? So we have a dedicated library for prompt. Why? By the way, very good, you can say, question like why. So in order to answer your why, let me just ask you a simple question. Okay. And by the way, I have a quick question. We are not importing our API key. How it is able to call it? How it is able to call it? Oh, makes sense, because I think it has automatically loaded everything in our .env. So let me just add that thing as well, because we are not loading all the .env functions, but obviously this is a smart code editor. If you face anything, then you need to import this particular environment variable. Sometimes if the editor is smart, they can automatically import everything in the environment, because that makes sense. It is created in the root directory, but if you want to do it, you can do it like this. From not Langchain, this is not related to Langchain. This is like pure Python, import OS. And then we have a function called load.env. And for that, you need to import one library. It is called, let me open this terminal. This terminal, no terminal has that activated. Oh yeah, this one, perfect. So now the library says uv add load.env. Perfect. So this is the particular library, load. Ansh, Lamba, say load load.env. So how we can just say, we will simply say from load or import load.env, and then we simply need to run the function called load.env. What this function does, this function doesn't do anything fancy. What this function will do, it will simply load everything which is saved in this particular .env file. If you have API keys, secrets, variables, everything, it will load that thing into this particular notebook. Why we didn't need to write this? Because obviously this particular code editor is smart. It would have already loaded it in our system, so it is fine, but usually you should add this. So I'm simply adding it here so that if you see the error, you can simply refer it, and you should do that. Let me just run it again, pick the virtual environment, and that's it. Make sense? So this is loaded. Now in order to set this particular environment variable, you can also write one more command. It says os dot, by the way, there is no need to set it, but I can just show you in order to test it. So I will simply shift this code cell to here. Now I want to make sure that my .env variable is loaded. How I can just make sure? I will simply say if os.environ .get Openai, that means if it exists, print bro API key variable exists, because obviously I do not want to show you, but this is a confirmation. If you see this message, that means the variable name is created. Okay, and it is taking a lot of time. So as you can see, it says bro API key variable exists. That means this function has loaded and created all of the environment variables. I can also say else value error open key not found. Perfect. So I hope you understood this concept. This is like a very small thing, but it is very important. So again, this function will, let me just write it for you. See, I'm doing so much for you. This function will load all the variables from the .env file and will make them available in the os.environ dictionary. That means environment variables. Perfect. So it will automatically create environment variables for us for all the variables which are there in the .env file. Perfect. And you should add this code in your all the notebooks. Yes, in all the notebooks. Let me just make it available here. And I know like why we didn't see any kind of error, because we loaded everything in our .env in the root directory, but it is a good thing to do this here. Perfect. Perfect. So now we have added this thing, so we are good. Because I was just looking at the code, I was like, why we didn't create this thing and it is still working? Because thanks to anti-gravity to some things, and bro, there are some bugs, so you need to fix it. So now I was just talking about prompts. So let me just write prompts. Ooh. Prompts. So whenever you just talk about prompts, now basically what are prompts? Prompts are the messages that are sent to the LLM. Simple thing. So that means messages and prompts are same. In a nutshell, yes. So why do we have two different categories, messages and prompts? Messages are like more static way of sending the message to the LLM. Prompts are more dynamic way and more, you can say, user friendly. Let me just show you one thing. So let's say, let me just write it for you. Prompts are more user friendly than messages. Perfect. So now let's say, let me just share the use case. I want to send a message. I want to send a message to what? To LLM. And I want to say LLM dot Openai dot invoke. And let me just create the my messages first of all. Let me just copy it from here. Perfect. This time I want to say, tell me a fun fact about, let's say, honey. I want to know the fun fact about honey. Okay, simple. Okay. I will simply say invoke content and I will get the message. System message is not defined. Very good. We need to run this as well. Okay, let me run this. Let me run this. Okay. Okay, perfect. So if I just run this, I will get the message about honey. Okay, makes sense. Makes sense? Okay, very good. Perfect. Bro, fun fact, honey basically never dies. Oh, really? Archaeologists have found jars of honey in ancient Egyptian tombs thousands of years old that, oh bro, that was still edible. That's because honey's low water content and high acidity keep bacteria and microbes from growing. Wow. Wow. It takes about 2 million flowers visit. Oh man. Honey is mysterious. So now we have got the fun fact about honey. Right? And let's say we don't need to set this system message. We are just okay with that. But this is the thing. We want to set the human message dynamically. If let's say you are building something, okay, and you want to get this message from a user, right? So how will you get it? Every time, will you hard code it? Will you go to your backend and you will change the code? Obviously no, right? So what I can do, I can simply get the input from the user. Okay. I will get the input from the user. Let's say input equals input function, or let's say user input equals to input. What do you want to ask? Simple. I can create this thing. Now user input will be the topic of the fun fact. Now I want to make it dynamic. How I can just make it? Now I will use it something called as prompts. So this thing you already know, right? I can just delete this, right? So I will simply say from Langchain core. Now again core, because core is like very important. Core dot prompts import prompt template. We have something called as prompt template. Now what is this prompt template? Prompt template is a kind of special, you can say, module that we have in Langchain core class, which we can build, which we can use to build our prompt dynamically. Really dynamically. Okay. So now what I will do, I will simply say input, dynamic input, let's say dynamic input, or then let's say dynamic prompt, because everything is prompt. I will say prompt template dot from template, prompt template dot from template. Okay. Then I need to write the prompt. I will say write a fun fact about. Now I do not know the topic. This is dynamic. Have you ever worked with f strings in Python? It is very similar to that. It is very similar to that. But obviously, we do not use f strings directly because people can use this same class for so many other purposes as well. So we simply write a function, or you can say write a fun fact about topic. Now this topic will be coming from the user. Make sense? Okay. So I'll simply say dynamic prompt. Okay. And prompt template dot from template, write a fun fact about topic. Now what is this topic? Topic is user input equals input, enter a topic for fun fact. Perfect. Makes sense? So this will bring the topic from the user in the runtime. Okay. This is the dynamic prompt, prompt template dot from template, write a fun fact about topic. Simple. Now I need to inject user input into this thing. User input into topic. Make sense? Okay. User input into topic. Okay. So now what will happen? If I say dynamic prompt, that's it. If I just show you the dynamic prompt, do you know what will happen? Do you know what will happen? If I write dynamic prompt and I simply write this, let me just run it, and it is asking me to put the fun fact. I will simply say this time, let's say flowers. Okay, hit enter. Now it has created this function automatically. Prompt template, input variable topic, which is the topic variable. Input types, we do not have any kind of type. Partial variables, we do not have any kind of partial variables. And it has injected this particular thing automatically. See, template, write a fun fact about topic. This has injected this variable, but not the value of the topic, but topic variable only. Topic variable only. Now if we need to inject the value as well, I will simply say dynamic prompt dot invoke, and then you can say dictionary topic is user input. What did I do? I simply invoked it. Okay. And I passed a dictionary. Key is topic, which should be exactly same like this, and user input, which is this one. User input is what value I will be passing. Now let's try to run this again. You will see flowers, hit enter. Now see, it has created this prompt for me. Text equals write a fun fact about flowers. Wow. And now we can pass this value to my LLM. I will simply say ready prompt, because this is a ready prompt which can be used in LLM. I will simply say LLM dot invoke dot content. Perfect. Now let's run this again. I will simply say this time, let's say flowers. Okay. Hit enter. Now this time what will happen step by step? I have just provided the message about flowers, right? It will inject that thing using invoke method, and it will create the ready prompt, which is this one, which doesn't have any kind of variables because it has injected it using invoke. And this ready prompt will go inside the LLM. Simple. And now we have got the fun fact. What looks like a single sunflower or daisy is actually cluster of hundreds, sometimes thousands of tiny flowers. What? Called florets. I think I read about florets in my 10th standard. I think so. Floret can produce a seed, so a sunflower head is a whole bouquet. Oh, wow. Okay, so now I hope that you have got the context. Like, why do we use template? Now you will say, Ansh, Lamba, do you know what? Everything is fine, but that thing is missing. Which thing? This thing. This thing is missing. This talk nicely and be a little polite. How we can just set the tone? How we can just set the tone for our conversation, bro? This is required, bro. We have to tell Simran, like, talk nicely to Rahul. We have to tell it. Okay, if you want to tell LLM, so what you can do, you can use something called as chat prompt template. There is another class. So if you do not want to set the tone, you will use prompt template, which is very similar to your f strings. If you want to set the tone the same way you set here in the messages, we have a class as well. What we? Are you the part of Langchain? No, but yeah, not now. Maybe soon. So yeah, so let's say from Langchain.core or core.prompts, I will import chat prompt template. This is special. In this, you can just set the tone as well. So I'll simply say, now my prompt will look like this. Prompt template. I will say chat prompt template. Now I will say from messages. Here we say prompt template dot from template. Here we say prompt chat prompt template dot from messages, because we are creating a messages list, right? Messages. Now this is a list. Now this is very important. Now we do not use system message, human message, AI message, whatever. We simply use a kind of tuple, and we simply say user. User means me. Rahul. User means Rahul. Okay, and it is the request, write a fun fact about topic, right? Now the second thing will be system. This is tone that we are telling Simran, right? System, you are a polite assistant. Simple, perfect, makes sense. So this is the list that we need to create. But here we do not need to write system message, human message, and all those things. No, chat prompt template class will automatically do it for us. Do you want to see? Let me show you. Prompt template. Let me show you the ready prompt template. Ready prompt, or let's say ready prompt dot invoke. Let's say we want to write a fun fact about AI. Do you know what it will create for us? What it will create? It will create the same thing like this. But we do not need to do hard work like this. We can simply say generate this prompt for us using chat prompt template. See, chat prompt template value, messages, system message. See, we didn't write system message. We simply write system, and we simply write our message, and it automatically parsed or created this particular string. System message content equals to this and blah 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 blah. See, I can even display you the better results. So I will simply say dot messages. See, this is a list. This is the same list we passed here, but this time we have more control because we can just inject the variables in the runtime and we can get the message. Make sense? Okay, makes sense. And obviously here I am just hard coding it, but we can just ask the user for it. User input, enter a topic. Perfect. Makes sense. And then we can pass this particular prompt to our LLM, right? I will simply say ready prompt. Yeah, you can just pass the ready prompt. You do not need to cut down the messages and all. It is fine because this LLM is has some good understanding of the context. It can just handle that thing. But if you just want to be pro, you can simply say messages. If you just want to save some tokens, if you are a pro developer, yeah. So let's try to run this, and this time I want to run a topic about, let's say, code editors, let's say, or let's say Google. Let's read the fun fact about Google. Google's name is play on the word Google, one followed by 100 zeros, chosen to reflect the founder's mission to organize a huge amount of information. And before that, the search engine was actually called as Backrub. Oh, this, I didn't know this. The search engine was actually called Backrub. Okay. Okay, so this was all about your templates, your messages, whatever we use. Make sense? And I hope that you have clear understanding. Now the good thing is you can create as many variables as you want to in your messages. Make sense? What do I mean? Because let's say you want to define multiple. Let's say you want to choose the system tone as well on your own in the runtime. You are a tone assistant. That means I will set the tone as well. So if I just ask this now, I will simply say user tone, enter a tone, right? So I will simply add this variable as well here. So I can add as many variables as I can. It's not like I can only add one variable while just creating this prompt. So I can just run this now. It will ask me topic. Let's get the fun fact of Microsoft. Okay, tone is, let's say, funny. Let's see what we get. Let's see. Microsoft started in 1975. Microsoft, yes, with hyphen. Oh, okay. And it was founded in Albuquerque, New Mexico, not Seattle. Okay. Proof that one of world's biggest tech companies literally grew out of the desert. Oh, wow. And outgrew its punctuation. Yes, this was a fun fact. Okay. So this was all about your chat prompt templates and templates that you use. Make sense? Make sense? Make sense? I hope that you have a clear understanding. Very good. Now we are going to talk about a very important topic. It's called structured output with LLM. If you are aware of something called as Pydantic, then it will be a piece of cake for you. If you are not aware about Pydantic, let me just tell you what is that first of all, because if you do not know about Pydantic, you are missing very important concept, okay, in Python especially. So let me show you what exactly is Pydantic. So let me just open my browser and let me just write Pydantic. Basically, Pydantic is nothing but a kind of parsing plus data validation library, both. Parsing plus data validation. See, Pydantic validation observability. Let me click on this. Oh, they have changed their UI. Nice. Earlier it was like very pinkish. Now they have just changed it to purplish. Okay, that's cool. So now, by the way, where's the documentation? Logifier enterprise blog documentations. Okay, Pydantic validation. Yes. Okay, this is perfect. So this is basically their official documentation that you should read. And don't worry, I will also tell you about Pydantic very quickly because you'll be just directly using Pydantic with LLMs. Basically, as I said, Pydantic is nothing but a kind of library which helps us to validate our data, validate our output, and parse it as well. It is both parsing and validation, both. Okay, so this is a code that we write from Pydantic import base model. Base model is a class that we use or inherit into our class, and then we just create our schema and we can do a lot of things. And you can just read this as well, like this is the kind of schema that they have created, and they are saying why use Pydantic. Powered by type hints, speed, JSON schema, strict and lax mode, data classes, TypedDicts. So if you are familiar with data class as well, if you are, then it is like very simple for you. Okay, if you are familiar with TypedDict as well, then it is also very familiar for you. If you are not familiar with anything, don't worry, I will just make you explain this. Make you explain what I'm saying, bro. Wait, it's really cold here, so I don't know. So let me just take you to my notepad. So basically, let me just tell you about this thing because this is very important. Pydantic. So now what is Pydantic? What exactly is Pydantic? Pydantic is nothing but a kind of data validation and data parsing library. So let me bring Rahul. So Rahul, let's say Rahul is building a, let's say, function, a normal Python function, right? And that function, okay, that function should have some schema. Schema means key value pairs, anything, right? Let's say this Python function, it can be like literally anything, but let's say Python function. So let's say he is writing this Python function and he expects the output specifically in the form of schema that he wants. Okay, fixed schema, or I would say, yeah, fixed schema. Schema is a, you can say, right word. So he wants fixed schema. Make sense? Okay. Now we know that whenever we create our own Python functions, okay, we define return, what we want to return. But let's say you are using LLM. Okay, you are using LLM to do that work. Now LLM is what? LLM is LLM. LLM can generate the output in that particular specific format, and sometimes it will not. Sometimes it will not. So in order to direct LLM, hey LLM, listen to me. Hey Simran, listen. you need to reply with this schema. You need to say key this, value this. For example, if I bring my anti-gravity here, so if you observe, what is that particular key it is using? Nothing, literally nothing, right? So let's say I will say user message is this one, write a fun fact about topic, return the result with return the result in key value pair in a JSON, or let's say in a key value pair with key equals to response, with key as fact and value as fun fact. Perfect. Let's say I'm directing LLM. I'm providing some information to this LLM. Okay, let's try to run this. Let's see what happens. Enter topic, let's say honey. Tone, let's say funny. And let's try to run this. Perfect. Now, can you see the difference? Now I have got the response with fact as my key and value is the response. So what I did, I directed LLM to generate the response with specific key and value pair. What is the benefit of it? Let's say my downstream. Now you will say, what is the advantage of it? Let's say the downstream of this particular function is using that key. Makes sense? Like maybe they are dependent on this thing. We have another Python functions. Okay. Dependent on this. So we have dependency. Cool. So that means we need to make sure that this Python function basically actually LLM. Okay. Because we are using LLM. So this LLM will generate the fixed schema and it should not generate something on its own. Simple. This is our goal. This is our end goal. This is Rahul's end goal. Make sense? Fixed schema dependent on downstream function. It can be anything. It can be anything. We do not know. Maybe data scientists are using it. Maybe data analysts are using it. Maybe someone else is using it. We need to make sure our schema is intact every time. So one way of doing that is, you have already seen, directing LLM in the prompt. But obviously we cannot direct it in the prompt. Like we can, as you have seen that it is successful here, right? Let me just write it for you. Let me just remove it from here. Let's create a new notebook so that you will have a better understanding. Let's create 3 structured output .ipynb, and this is my code, or let's create markdown. First of all, we will look at prompts, basically guiding in prompts. Guiding in prompts. Make sense? This is like one way of doing it because we have so many ways. One is guiding in prompts. And what is the way to do that? First of all, we need to load this thing here. Okay. Attach this environment variable. Then we can load this entire thing, right? Perfect. And I can attach it to this one. Okay, makes sense. And I can remove this thing because I don't want to apply this thing. And I will simply say topic. Simple. About, let's say, honey. Make sense? Okay. Or I can even remove this thing because now we are focusing on LLM. So I do not want you to be confused on prompts and all. Okay, so I will simply say LLM Openai dot invoke. Tell me a joke. Let's say, tell me a joke. Perfect. So we have this. Let me just try to run this. Langchain core. Okay. LLM Openai is not defined. Okay. We didn't define the model. Really? Okay, we can define it. Not a big deal. This is the model. Okay. Tell me a joke. Now I will guide this LLM model, okay, to generate the output in a specific, you can say, schema. Makes sense. I will say, tell me a joke. Generate the output in key value pair format with the following keys: setup and punchline. Make sense? So it will be having two keys, setup and punchline. Okay, let's try to see the answer. It should return a dictionary, and let me just say result, and then I can say result dot content. Let me just run it. Okay, so I have setup and I have punchline. See, so it has actually generated the output in the key value pairs. That is fine, and I loved it. Setup: why did Scarecrow win an award? Because he was outstanding in his field. Okay, wow, nice joke, very nice joke. 10 out of 10. Okay, now one thing is clear, that we can guide LLM in the prompt, but it is very simple when we have like a very simple prompt: tell me a joke, tell me this thing, tell me that. But when we have, let's say, a very detailed prompt, very big prompt, dynamic prompts, when we are just running complex workflows, we cannot guide the LLM to generate the output in a specific format, right? Then we have to follow a structured approach. That structured approach is called Pydantic. Let's try to discuss that. And you will understand Pydantic, don't worry, even if you do not have any knowledge with that, I will just make you understand it. Structured output using, let's say, Pydantic. Using Pydantic models. Now, what is Pydantic model? Okay, and you will also see the difference between Pydantic and TypedDict. Just stay with me. Now, using Pydantic model. So now we need to make sure that we are guiding LLM in a more formal manner to generate the output in a specific structure, right? So we use a library called Pydantic. Import base model. Now, what is this base model? Base model is a class that we use to create our schema, right? And how do we create our schema? We simply create a class, and I can say, let's say, LLM schema. Simple. And I will inherit this base model in my normal class. Simple. Now within that, I need to define the key value pairs. Not key value, basically the schema. Like all the columns that I need, all the keys that I need, everything. I need just two things. One is, let's say, what was the schema here? Let's use the same one, setup, so that you can relate better. Setup, right? And what is the data type I want? Oh, that means we can even control the data type of this thing as well. Exactly. I will say string. I want my setup key is of string type. Then I will define punchline, and this will also be of string type. Make sense? Very good. Now this is my class. Let me just run this model. That's it. So this class is created. Do you know what? Now, if let's say I want to use this particular LLM, basically use this class, use this schema, I cannot use any other thing. What do I mean? Let's say I want to create a class. So I will simply say object equals LLM schema, right? And I want to just create an object of this Pydantic. So I'll simply pass a dictionary. I will simply say, let's say setup, right? Setup will be setup, and punchline will be, let's say, punchline. Punchline will be, let's say, punchline, or let's say some setup, right? And punchline will be, let's say, some punchline. Okay, perfect. And now let's unpack this list like this dictionary, and let me just try to show you the output. OBJ. So what did I get? I got this Pydantic object. If I want to now use this object, I will be using like this. OBJ dot, let's say, setup. I want to use a setup key within this. I will write like this. I will get this some setup. Got it? What is the advantage of it? I told you that this is a kind of data validation library. If I pass some wrong thing, let's say I do not pass setup, I pass, let's say, ketchup. Wow. Word playing, Ansh Lamba? No, nothing else. So let's say ketchup, some setup. Now, if I try to create this object, it will throw the error. Why? Validation error. It will say, bro, you cannot do this. You cannot do this because I can only accept either, not either, basically both. I can accept setup and punchline. If you will not provide me this thing, I will not allow you to create an object. Wow. That means if LLM generates an output and LLM does not follow our schema, it will not allow LLM to generate the output, and it will protect us to just deliver that pseudo schema or let's say broken schema to our downstream workflows. This is an amazing thing. This is a kind of data validation check. Very good. Ansh Lamba, does it only check on the keys or it does something else as well? It does this data type check as well. For example, let's say I pass some integer value here by mistake, 1, 2, 3, then also it will fail. See, validation error again, because I am expecting of string type. So this is called validation. Okay, so data validation is done. Now what about data parsing? So this step is called data parsing. When you are parsing the values and it is creating this Pydantic object. Let me just correct it. If I say some setup. So what I did, I simply parsed this particular class and I parsed my arguments. Setup, some setup, punchline means some punchline. Makes sense? And then only I got my object. Wow. This is literally wow. And do you know what? Now let me just show you with LLM. So I will simply say LLM structured output because I'm creating a new LLM object, right? I will simply say my normal LLM, which was Openai, and then I will say with structured output. And now I need to pass the schema. And what is the schema? This is the schema. LLM schema, right? Pass this. LLM schema. Perfect. Now if you use this model, now if you use this model, this one, this will generate every time the output in this particular structure, and I will not even tell LLM that generate the final output in this structure. This is the power of it. What one pro tip, that whenever you are defining your class, you should always define a kind of description. Why? Because LLM is not magic. LLM will use your information as context. Now just tell me one thing. If you are a human, if I will say you need to create a joke, okay? And I know you are a great comedian, you will just create it like this. So let's say you create the joke and I say you need to generate the output in these two key value pairs. Do you know like what should be the setup and what should go in the punchline? Obviously no, right? So I will tell that what should be go in the setup. I will simply say field that I need to first of all import. Perfect. And then I will write field description, setup for the joke and joke. Setup for the joke and then punchline for the joke. Make sense? So these are a description. These are very important because LLMs are all about context. Simple. More and precise context you will provide, better applications you will be able to build. Simple formula. So this thing is done and let's try to test it. If it is working fine, I will simply say, tell me a joke. That's it. I will not tell LLM to generate the output in any structure. I will simply say generate a joke. Let's see what it generates. I will simply say dot content. Let's see. Okay, LLM schema object has no attribute content. Makes sense. So I can remove this content. Makes sense because that is a Pydantic object. That is a silly mistake. Perfect. Now what I got the response in the form of LLM schema, which is this class. Then setup. One key, its value. One key, its value. Perfect. This is not just a generic string. This is a Pydantic class object. I can even show you. If I say result, and if I say type of result, let's see what we get. See, this is an LLM schema object. If I want to use any key value pair, now I can use it easily because now I am sure that LLM will generate the output with those keys. I will simply say result dot, let's say, punchline. Perfect. Let's see. Perfect. That's how you guide LLM to make better AI agents. Because remember our discussion? Our main agenda is to build this kind of workflow. So let's say this output of this node is actually like this node is dependent on this one, right? This is the upstream for it. So if it generates something else, this whole workflow will be broken. So we need to make sure that we pass the exact schema that we should pass. We should not tell everything, LLM please generate this, LLM please generate that. Build LLM objects smartly. This is the concept of Pydantic. If you are learning Pydantic for the first time, take some time to digest this information because this is new. If you already know Pydantic, then it will be like piece of cake for you. You are simply implementing its, you can say, feature. That's it. Make sense? I hope like it was easy. Now let's talk about the third type, which is not very recommended, but people still use it. Let me just tell you what's that. It is called as TypedDict. Okay. Using TypedDict. Perfect. Now what is TypedDict? TypedDict is exactly same as Pydantic. Okay, exactly same. Then why are we using two things? Okay, let me tell you. So this is exactly same as Pydantic. But Pydantic is like the principal, you can say principal of the school. Okay. And TypedDict is like the class teacher. Wow, Ansh Lamba. Just solve this puzzle that you have just created. Okay. Principals are like very, very strict, right? They will not listen to you. They will simply do this. Like in my school, like I got this. So they will not listen to you. They will not correct, like they will not listen to you that why did you make any mistake? If you made the mistake, tar. So they are like this. Class teachers, on the other hand, if they are good, they will listen to your mistake. Even if you make a mistake, they will simply say, okay, do not do it next time. Exactly same thing happens here in Pydantic models and TypedDict. So you define the schema for sure. Let me just show you. So I will import the TypedDict from typing, import TypedDict. Okay. And here I will create the class same way I have created there. Class, let's say LLM schema TD, that means TypedDict. And I will add TypedDict class, same way, everything is same. Then again, same things, name, age, or no, not name, age, let's say setup, string and punchline string, same, right? See, exactly same. Now, if I just show you, let's create this object. Okay. Now what will happen if I just create an object of this? Object equals LLM schema TD and LLM schema TD, and if I pass a dictionary with same thing, setup, let's say some setup. Why it is why again writing tier down. Let's say punchline and let's say some punchline. Perfect. Let's say some setup. If I do this, what I will get? I will get dictionary, not an object, dictionary, simple dictionary. Okay. If I want to use any object, I can use it like this, setup, or I can use .get option as well. Simple dictionary. This is not an object, simple dictionary. Okay. And do you know what is the advantage? Why I just said like it corrects your mistake. Let's say you wrote it here, catch up. What happened with Pydantic? It failed, right? Let me just show you. It won't fail. It will simply say ketchup. What? What? That means you made a mistake. You wrote ketchup, but still it will not fail. Why? It will create the output using your mistake, and it will simply give you the error on the typing part. Basically, these are for type hinting. Type hinting. So when you're, let's say, typing something wrong, you will get the error while typing it. It is not runtime error. It will not fail your code. Okay. So this is like a class teacher. She will say, okay, do not make a mistake next time. But if you made a mistake in front of your principal, he will say, come here, bro. Come here. Come to my office. And I used to just get those announcements. Like I was in, I think, class 8 or 9th or 10th. And we had a mic. We had like cameras in all our classes. Okay. And if someone is like doing something crazy in the classroom, a principal used to watch everything in the cameras. And if you made a mistake, bro, you are gone. So on, I would say every week, there was an announcement used to happen in our whole auditorium, whole floor, I would say. Ansh, Lamba, come to the principal office. I was like, oh, bro. So yeah, crazy stuff. But I used to go to the principal office with all of my friends. I never went to the principal office alone. Alone. Because whenever I go there, like whenever I used to go there, I simply take names. I used to take names. See, I was not alone. I was with this, and then all of those people would also come down to the principal office, and let's have a group discussion together. Okay. Crazy stuff. So now I was saying that we can create this object like this. Simple. Now you will say, Ansh, then what is the benefit of it? There's a benefit. We can still use this particular class to provide the context, because we simply need to provide the context to LLM, right? We simply need to provide the context. I can simply say LLM structured, or let's say TypedDict, right? And I will simply say LLM Openai dot with structure output. Perfect. And this is my LLM schema TD. Now if I ask the same question here, this thing, I will get it. I will simply say result. Perfect. LLM OP. What is LLM OP? Where is LLM? Oh, OpenAI. I think we just need to use TypedDict. Perfect. So here you will see that you will still get the answer in the form of dictionary, but not in the form of Pydantic object. Not in the form of Pydantic object. Wow, very good. Make sense? Make sense? Very, very, very good. But what is the advantage? If let's say your workflows are not very, very error prone and you are not very much dependent on the same keys, then you can simply use TypedDict for just as a context. But when your workflows are very, very strict and you do not want them to create any random key on its own, you can use Pydantic. So it's totally depends upon the Pydantic. And do you know what's my philosophy? If you're using a specific schema, right? And if you want to just use a specific, you can say, guide to your LLM, just go with Pydantic. Go with Pydantic for the final output. And if you just want to provide some context to your LLM, then simply go with TypedDict. Simple. I hope it makes sense. Like when should we use Pydantic and when should we use your TypedDict? Make sense? Okay. So now let's try to cover this important topic, and I would say this is one of the most important topics. What is this topic? Chains. And obviously we are learning Langchain, so as you would have already guessed that this is really, really important. Chains. Basically what are chains, or basically what is a chain in Langchain? If you are a data engineer, you can better relate this concept with your something called as pipeline. So being a data engineer, chains are very similar to the pipelines. And what are pipelines? Pipelines are nothing but sequence of tasks. If you would just define it in one line, sequence of tasks. So let's say, where is Rahul? Rahul will become so popular now. So let's say this is a data engineer, okay? And now this data engineer needs to build the entire pipeline. So how this pipeline look like? Let's say this is the task number 1, maybe. Then task number 2, maybe like this, maybe like this, maybe like this, like very simple pipeline, right? And if you're a data engineer, you would know like how to build this. So let's say this is 1, this is 2, and then this, then this, then this. Very simple pipeline, right? Basic pipeline. So now what we need to do being a data engineer, let me first of all remove this. So now let's say this, you have this pipeline. In data engineering language, we just call it as a pipeline. And in AI engineering language, or basically in LangChain language, we just call it as a chain. Okay? Chain. Remember one thing, this is my personal tip. When we just create pipelines, we create small pipelines, right? Listen to me carefully. So let's say this is only one pipeline, and this is a very simple, straightforward pipeline. And if we want to create complex pipeline, what do we create? We create dedicated nodes. So let me just make you understand this concept with our previous example. So let's say we have this particular LangChain, right? So now I am talking about only this part. See? So let's say you want to build something like this. What is this thing? This is a pipeline, but smaller pipeline. Perfect. What is this? Pipeline in itself, smaller pipeline. What is this? Smaller pipeline. And when we combine all of these things, this become our parent pipeline, or basically the workflow. Make sense? So what we are learning currently, we are learning about chains. So chains can be complex, but if you want to become, you can say efficient developer with LangChain, do not create long and complex chains. Always create smaller chains, and then you can combine those chains. Are you getting my point? So let's say one chain like this. Okay. One chain like this. You can just create only one node for this chain, only one. And then you can just connect, or let's say you have, let's say similar chain like this here. You can connect it. Make sense? So instead of creating the whole thing in one go, you can just have this one chain first of all, second chain, then you can just connect both the things. Do not make everything available within single chain. It will be very hard to debug. This is my personal recommendation. It's not like hard and set rule that you have to break down the chains, or you cannot build long chains. These are like best practices. Again, the choice is yours. If you are a developer, you can just do whatever you want, but this is the concept of chain. Make sense? So this sequence of tasks is basically a chain. Make sense? Very, very good. Now you will say, Ansh Lamba, like in data engineering world, we just use maybe Airflow to build the chain, basically to build the pipeline. We also use Azure Data Factory. We also have, let's say, AWS Glue and all those things. What do we use in LangChain? Because we have just covered how we can just make wrappers on top of our agents, prompts and everything. The good answer is, or you can say the good point is, we can just use everything within the LangChain itself. You do not need to combine it with that third-party tool or whatever. We have like inbuilt functions available. Let me just show you. Let me just create a new folder. Let's call it as chapter 2. And let's create our first notebook. And I will simply say basic chain, or basically first chain. First chain.ipynb. Okay, perfect. Now I have already talked about what are chains. Chains in LangChain. Okay, perfect. So now let me first of all import that boilerplate code. So this is the code. Let me just bring it here. Perfect. And let me just select the markdown, this kernel, and make it as Python. Perfect. Let me run this. So this is our boilerplate code that we have just copied. Let's wait if our LLM OpenAI is created, because see, this anti-gravity is really new and I have been using for I think almost a month now. I started like using this last year and I personally feel like it's a great tool. Obviously it is free. Second thing is it has like so many bugs. Like sometimes it takes so long to just run some cells and we have to just close it and open it again. So there are some bugs and that's why they have just kept it for free. I don't know. Okay, see, now it is also taking so much of time. Like it should not take much time. If I would be just running the cell in my VS Code editor, it will be like this. VS Code is like very stable and very good. So yeah, let me just close it and open it once again. Let's see. So I have closed the anti-gravity and I have just ran this again and now it is done. Sometimes it takes like this much of effort. Okay, so our LLM OpenAI instance is created. That means we can now just call the models. Now let me just show you a basic, you can say chain that we'll be creating. And this chain is very cool. So now you know that how do we connect with LLM and how should we connect to the LLM? We should always create a prompt first of all, right? Obviously. So we will be creating a prompt. So let me just write first chain, right? So in this first chain, I will first of all create the prompt. And how do we create the prompt? You should know now. You should know now. You should know by now. So now I will simply say prompt template, because first of all we create the template, right? Prompt template equals chat prompt template, and let me just import it if it is not imported. No, it is not imported, so let me just import it from Langchain core.prompts, import chat prompt template. Okay, perfect. So we have chat prompt template.from messages and system message, you are a helpful assistant, simple, and human is input, because we do not know like what will be the input. Okay, and we are creating a, you can say, chain which can take any value, like basically anything. It is not just a, you can say, joke generator or fun fact generator. It can take anything. So that is why I'm not guiding anything in the human message. I'm simply saying input. Sorted? Good. Now this is my first task. Okay, let me just write it task 1. Task 1 prompt. I want to create task 2. Let me just first of all run this. Then I will say task 2, and this task 2 will be LLM, right? Because I want to send this message to the LLM. So I'll simply say LLM OpenAI. Okay, let's actually automate this as well. So we already have LLM OpenAI here. So I will simply repeat this step. That's it. Perfect. So this is our LLM. Third step will be, I want to use a parser. Now what is parser? If you remember, if my previous notebook, if you will see that every time I use something called as content, if I want to fetch only the content value, see, dot content, dot content, dot content. Like every time we see dot content, because if we do not write dot content, we will get the unnecessary things as well, such as parameters, those things, let's say token size and all, and we do not need to show that thing, right? So one option is we can create, like we can use dot content, right? Or we can use a built-in function in Langchain which is called string output parser. So what that output parser will do, it will take your generated response and it will only fetch the content out of it, and behind the scenes it is doing the same thing. It is writing dot content, but it is automating that thing and you do not need to write it again and again. So I can simply say from Langchain dot, I think, parsers. Let me just check here. What did we use? Output parser. Let me just check the class for it. Let's try using first this dot parsers import string output parser. Yeah, let's try this. No, let me just check the library for this. String output parser. This is our Langchain. String output parser Langchain. What is the library, bro? What is the library? Yeah, it's called Langchain core dot output parser. Okay, makes sense. Output parsers. Okay. Perfect. Yeah. So we have a function called output parser, right? See, like this. Now I can just use this. How? Let me just show you. Task 3, string parser. So I will create an instance of this function. I will simply say string parser equals string output parser. Simple. So how many tasks have I created? 3. Perfect. If I will be just manually running all these tasks, I know how to run this. First of all, I will invoke this template by feeding the value inside this. Then I will pass this prompt template into this LLM Openai. Let me show you. So first of all, let me just say manual. Manual thing, first chain. Let me just write it for you. Manual invocation. So manual invocation will look like this. So first of all, I will simply say prompt template. So I will say template equals prompt template dot invoke some value. Let's say, and what is the key? Input. Okay. What is the capital of France? Then I will say LLM dot invoke template, and then I will say final output is final result equals this dot. Let me just store it in the result, and then I will say result dot content, right? This will be my manual invocation of every single step. Just imagine that you want to run this particular chain and you are just manually invoking every step. That's how you build data pipelines? No. So how you can just create it? So I will simply comment it out because we are not manually running it. If you want to just run it, you can, but I am not running this at all. Okay. So I will say chain invocation. So I can invoke it through the chain. And in order to invoke this in the form of chain, I will be creating a chain, obviously. So I will simply say chain equals whatever value you want to use. And there are basically 2 ways to create the chains. I personally like the first one. So what do we need to write in this particular method? You simply need to use a pipe operator, which is also called as LCEL, Langchain expression language. So what do I need to write? I just need to display or basically write the function in the order I want to run it. So first of all, I want to run prompt, right? Prompt template. Then I will use pipe operator. Then I will simply say LLM Openai, my second function, task basically. Then this, then pipe operator. Then I will simply say string output parser, basically string parser. Perfect. String parser. Perfect. So this is my chain now. And you know what? I just need to say chain.invoke and I can pass the dictionary input. Let's say what is the capital of France, whatever I want to ask. Okay. So now do you know what will happen? It will first of all invoke this thing, first function. Then it will invoke LLM Openai, and then it will invoke string parser automatically. Let me show you the result. Let me just run this. See, you are just getting the final answer automatically. You didn't run this manually, you didn't run this manually, you didn't run this manually. You are simply getting the final response as is. The capital of France is Paris. Really? Yeah. Okay, makes sense. Now, you will have so many questions in your mind right now, I'm so sure, because I also had so many questions when I was learning about Langchain. How this flow is working, how input is going, how the data is flowing. I know. Wait, I will just explain you everything. So how everything is going on. So let me just open this thing. So let me just show you how the things are happening. So first of all, we have, let's say, 3 tasks, right? So first of all, we have template. right? First of all, we have template, then we have LLM OpenAI, let's say LLM, just LLM, okay. Then we have string output parser. Perfect. So we have this chain, simple, sorted, and you know what will happen. First of all, Rahul will send the input. Now input can be anything, right? So input will go like this. Input, and he asked what is the capital of France. Just focus here because this is very important, and this will cover your all the fundamentals. And Rahul, so sorry, I'm just removing your name because I want to just put the input. Perfect. So this will go here as the input. Simple. Now this template will receive this as input. Okay. Let me just write it here, input. So this is the input. Okay. Let me just change the color as well. Let's say red. Okay, perfect. So this is the input. Okay. What is the capital of France? Because this requires this dictionary. If you just look at the template, how do we invoke it? We invoke it like this, right? Like this. Perfect. Now we will generate what? How our output will look like. Output will have obviously the template object, human message, system message. Remember, we discussed it in the fundamentals here in the messages, like how we just use the templates. Remember, like this. So now I think we discussed here as well, like how do we just create the prompts here. See, when we invoke it, what do we see? So now what will happen? This will generate the AI message, human message, something like that. Simple. Let's say it generated, let me just invoke it. You will say like, bro, we forgot, blah, blah, blah. So let me just run this particular thing, and perfect. This ran fine. And let me just run this, and let me just run this prompt thing, and I will not invoke this function. I will simply show you what ready prompt look like. Ready prompt content is very important. Now let's say, what is the capital of France? Now let me just show you the ready prompt. What is the capital of France? Okay, this is the thing. This is the ready prompt, right? And if you are using, let's say, chat message, let's say chat prompt template, then obviously the message will look like something else. Like if you are using chat prompt template, like here, if I just invoke this as well, just for you, I can show you ready prompt, and let me just comment it out here as well. Topic, let's say honey, and tone, let's say funny. So this is the value that I will see. See, chat prompt value, messages equals to this, and whatever values do we have here. Perfect. So I'll be having values like this. Make sense? So this will be my output. Yes, this will be my output, and obviously it is too big, but yeah, this will be my output. Make sense? Now I have this output, this output will actually flow from here, and it will go to here as input. Okay, it will go here to as input, or I can also move it here so that you can understand it better. So this will be my input, and this will go here. This will be my input. So output of one task will exactly be the input. Why it is so important, why I'm stressing so much here? Because the next topics are strongly dependent on this concept. So this output will become my input, whatever it is. We cannot tweak it because it is automated. Whatever it will generate, we have to accept it. V means LLM node. Makes sense? Now this LLM, what it will generate? It will generate its own content like AI message and quarks and whatever. And this will become its output. This output will become now input of string input parser, basically function. Make sense? This will become its input. Now this parser will generate what? Only content, because it will simply say dot content and whatever. We already know like what it will do. So this is the basically the flow of it. Like how does it work? Make sense? So I have just rearranged this with the values so that you can better relate with it whenever you will be referring to this particular nodes. So I hope now you know what is the intent. The intent is you need to be very sure while creating the chains, because the output of one node, basically task, will be the input for the next node, or basically task. If you are expecting here something else and your previous task is generating something else, then it will not work, because it will simply mess up with the you can say requirements. Because let's say you are here requesting a kind of different input variable and you are giving it something else, so it can actually break it. So this was a very simple example, that's why it worked extremely fine and we didn't need to make any changes. And by the way, Lamba, you were just talking about we have like two different ways to run it. Yes, so we can also run it with the help of runnable sequence. Now what is this runnable sequence? This is basically the kind of function that we can use in order to create the chains and basically run it. I personally like this pipe operator, but if you want to know, I can just show you as well. So you'll simply say optional from Langchain core dot runnables, I guess, import runnable sequence. So you can simply say chain 2, or let's say chain 1 equals runnable sequence, and in this particular list we just need to pass all of the functions. Functions means like all of the tasks that we have created. Make sense? Okay, so now I can simply pass like runnable sequence, and let me just say prompt template, and then LLM, Openai, and then we have output parser. Perfect. So we can also write it like this. LLM Openai is not defined. Wow. LLM Openai output parser. Very good. Code awareness, whatever model this anti-gravity is using. So see, we also got this value, but I'm a big fan of using this because it makes the chain more readable. We can easily define that you can say dependencies, and it is very much similar to defining dependencies in Airflow. We use like this operator in Airflow, tuck, and here we are using pipe operator. It's fine. So yeah, choice is yours if you want to use this one, because some people would like this one. So I'm not restricting you to just use one method, but you have the options available. Okay, perfect. So this was a very basic example of chains. Now in real life, we build chains which require some custom functions as well. What do I mean by custom functions? So basically, let's say you want to build a chain where you want to basically add some functions between this. For example, we have this chain template LLM parser. Parser means the final output. Now I want to add one more you can say task, right? One more task, and this task will pass this value to a different LLM. Okay, and what this LLM will do, this will behave as a kind of post generator. Let's say you want to first of all write a joke, right? And then you will simply get the message, and then you will just get the content out of it. Now in the second task, or basically in the second chain, what you can do, or basically second part of the chain, what you can do, you can now send this particular output to a different part where it will evaluate and it will make it in a form that you can just post it on your social media. Let's say you just want to create a post on LinkedIn for this particular purpose. So what you will do, you will then add a function in between. Why? Let me show you why. Because if you do not do that, if you, let's say, let me just delete this. Let me just delete this because you already know what will be the output of this. So let's say you want to send this thing to the LLM, and how do you send it? Obviously, we use this node, right? We use this kind of node, or basically task. Now just tell me one thing. If I want to send this message to LLM, what's the best practice? Obviously using template, right? So let me just bring template here, first of all, before even LLM. So when this output will go to the input, does that make any sense that I'm just sending this input like this? Yeah, it makes sense. Does it make sense? Think about it. Like, why did I explain everything to you regarding the output? Because now here the output is just generating the text. And how do we pass the input to any template? We pass it in the form of dictionary. Oh, so where is the dictionary? Where is the dictionary? Makes sense. And where's the key for that dictionary? Because we just create key value pairs, right? So we need to create one node which will be called as, let's say, custom node, or basically custom task. Okay, I will simply say custom. So this custom function, what will do, it will take the output of the previous task, it will modify it in such a way so that we can pass this value to the template in the form of a dictionary. So this will be dictionary maker. This task will be dictionary maker. Now Ansh, Lamba, can we just write our custom Python function as well? Yes. You can even convert your custom Python functions into the form of tasks. Wow. And how do we do that? It's very simple. You just create a Python task, basically Python functions, and then you use one function. It's called @. I think just forget about @. Just use simple one, runnable lambda. You can just use runnable lambda, and you can convert any function into a runnable. Runnable means this task. Wow. Yeah. You can even convert this thing into a runnable lambda. Okay. And do you know what? You can even convert this whole chain as the lambda. I will just talk about it, don't worry. But first of all, let's cover this custom functions. And I hope you got the requirement, right? So let me just write it here. Now we need to pass the input. And input is here. Here. Input is, let's say, here. Perfect. Input is here, right? Now this input will send this message to the template and then to the LLM, right? And then at the end we will use the parser, and this parser will send back the result to the user. Makes sense? This is our workflow that we want to create, basically our chain. It's a simple one, don't worry. It looks a little bit like tricky, but it's very simple. Make sense? Okay, let's try to build this and you will learn like how can we just create this kind of task. Let me just show you. So let's try to create this particular pipeline, chain, whatever you want to say. And I have just mentioned this quick note so that you will understand like why are we creating this custom task and what's the need of that custom task. Make sense? Okay, perfect. So now in order to do that, I will simply create a new notebook. I will say chain with custom runnable .ipynb. Okay, perfect. So now I'll simply say, let's try to import it. What do we need to put in the heading? It's fine. Perfect. So let me just run it. And you got the requirement, right? We need to just create that particular chain. So I will simply copy all the tasks of the chain first of all, and I will say chain with custom runnable. Okay, so here we have chain with custom runnable, and this is our task number 1. And what is this? List. Okay, perfect. And this is our task number 2. And this is our task number 3. Perfect. And perfect. Now we do not need to invoke it because we want to create more tasks. So here I will write task number 4, which will be my custom task, custom function, or basically custom runnable. Runnable is just a fancy name. Runnable is something like which you can run in the sequence. Okay. So I'll simply say def my custom function that I write. I will simply say dictionary maker. Perfect. Dictionary maker. Now input can be text of string format and it will generate dictionary. Okay. Now whatever I want, I simply want to return it like this. Return dictionary text key. Okay. And this can be customized. This will be as per your requirements. This will be as per your this requirement. Like what kind of key are you expecting in the template? Right? We are simply expecting the text key. That is why I am using text. If you want anything else, you can just customize it. I will simply say text. Simple. This is my dictionary. Perfect. Now in order to create this or convert this into dictionary, I will import something. I will say from Langchain core.runnables import runnable lambda. Perfect. So now this is not converted into a runnable now. This is just a function. If you want to run it in a sequence, we need to convert it into a runnable lambda. So I will simply say dictionary maker runnable equals runnable lambda, and then I will pass my function. Now I can use this object to create a chain. Are you getting my point? Because we cannot directly use a Python function in the Langchain, basically chain. We need to convert it or basically apply a wrapper on top of our function so that chain in Langchain will treat our function as a runnable. Simple. Make sense? Okay. This is our task number 4. Let me just run this. Perfect. Now the task number 5 is very simple, very similar basically, and simple obviously because you are on this channel. So this is like template for post that I want to post, right? So I'll simply say prompt, or you can say post equals prompt template dot chat prompt template, and here I will say UN message, helpful assistant. Okay. Or I can also say you are a social media post generator. Simple. Okay. And text, create a post for the following text for your favorite social platform, let's say for LinkedIn, right? So system and human message. Makes sense. Now this is my prompt post. So now if I want to invoke it, let's say I want to invoke it, how will I invoke it? Prompt template. Let me just import it. If it is not imported, where is that prompt template? I think we have here prompt template. Oh, I see. What is the issue? We are using prompt template. We need to use like this. Chat prompt template dot from messages. Perfect. So now let's say this is my prompt. If I want to invoke it, obviously I'll be writing like this. Let's say prompt post. This auto suggestion sometimes irritates. Prompt post dot invoke, and then I will pass a dictionary, right? Dictionary will be looking like this. Text, and let's say hello world. Simple. So I can only invoke it with this dictionary. If I try invoking it like this without this dictionary, and if I simply pass this text, this will work, but we need to just make sure that text is replaceable here, because if it works because we just have one variable here. If we have multiple variable, how it will know like which variable will take which value? So in that particular scenario, we have to mention this dictionary, otherwise it doesn't work. So that's why I'm creating that particular function called dictionary maker. And then once we have this prompt template ready, we can simply create another task, which will be LLM post generate the post, and this will be my LLM LLM OpenAI, as we all know, right? This one, and I want to use the same model. Perfect. Perfect. This is my task 6. I can even ignore this writing because we can just use the same object, right? LLM OpenAI, but I'm just simply writing it again so that you can understand it. Otherwise, like, see, it is the same thing. Why I'm writing this here? So that you can actually understand and relate to it more. So, and our next or basically last task is task 7. Output parser, as you know, string parser. And we also do not need to define it again because we have already defined it, but I'm again defining it for you so that you can understand it. Perfect. So let me just run all the things now. And now let's create the chain. And our chain is here. So now how we create the chain? Now you already know LCEL, Langchain expression language, right? So I'll simply say chain equals and all the tasks in the you can say sequence. So first task is prompt template, and then we have LLM OpenAI, then we have string parser, then we have custom runnable, which is dictionary maker, and runnable, dictionary maker runnable. Oh man, this dictionary maker runnable, which is the runnable instance of our function. Then we have again prompt post, right? Prompt post. Then we have LLM OpenAI again, because this prompt will go to LLM OpenAI, and then string parser. Make sense? So this is our chain. Now let me just hit this. What is the capital of France? And let's see what is the output. The output should be a post that we can just post it on LinkedIn, right? And this whole chain is now running. See, quickly geography refresher. The capital of France is Paris and it's more than landmark failed city. So this has created the entire post for me and it has done everything. So what it has done? The same thing that I have just demonstrated here. So it will simply create this thing like, let's say fun fact about honey, or it is just creating the capital of France. It will go to the input for this custom function. So what it will do, it will create a kind of dictionary, simple. And then this dictionary will take this output and it will send to the template. And that template will fill the variables, simple. Then it will go to LLM, then it will go to parser, and then it will go to us. This is the chain that we have just built. And that's how you can also build your chains. Make sense? Okay, very good. Now let's talk about this important concept called parallel chains, because see, we already know the concept, we already know the fundamental thing, right? Linear chains, as we have just discussed this, like how we can just create the linear flow. But obviously in your complex workflow, as you're building some more complex and more advanced level, you can say flows or chains, you will need this thing, which is called parallel chains. What do I mean? So let's say, where is that Rahul? Okay. So let's say this is a developer, okay? This Rahul, yeah, same person. This developer now needs to create a flow which looks like this. Let's say it has a kind of template, okay, which is a starting point, for every chain, I would say, every chain. And after this, it has LLM for sure. Perfect. Now it has maybe parser. Like parser is like optional, it's not a very big thing. So let's say it has like 2 nodes, right? 2 tasks. But now the thing is now going to be interesting. Okay, how? So now we do not have like linear step. We have parallel step. What do I mean? So let's say now we need to create this particular task. This can be anything. Just to take an example, let's say you want to analyze the summary of your data that you are processing, and it can be anything. Let's say you are getting the CSV file and you are just processing the data, you are summarizing data, and that's it. Cool. Okay. Now on the basis of that, you need to do 2 tasks. One, you need to draft an email or basically send an email to your manager regarding the summarization that you have received, because that is a kind of financial report, right? You need to do that thing. You need to send an email to your manager. And second thing, you also need to draft that particular thing in your documentation folder as well. Or let's say you want to send a message on Teams to your group chat. Make sense? So in short, I want to perform two parallel things. Okay. And whenever we just perform anything in Langchain, we have series of steps, right? So that being said, this will be a kind of chain in itself, right? Let's say this is chain number 1, parallel chain. And just for the simplicity, let me just add an arrow. So let's say this is a task. This is the task. Okay, perfect. So this is like chain tasks. And this is obviously the initial chain that was started. Perfect. So now we have this chain number 1. Perfect. And I can just create a box. Perfect. So this is my chain number 1. And similarly, I have one more chain for the Teams messages as well. One is for email, one is for Teams message, or you can say one is for email and second one is for personal use. You want to draft it, you want to save it, or you want to send it to, let's say, your director or whatever. Basically, you want to perform parallel tasks. So what will happen here? You will be creating these two parallel chains. Parallel chains. Wow. So this will be my chain number 1, chain 1, and this is chain 2. Perfect. Now you will say, Ansh, Lamba, is it a difficult thing to do? Please tell us before. Okay, what if I say it is a difficult thing? What will you do? Nothing, we will be just prepared. Okay, so the thing is, it is very easy. You first need to understand the concept. You have understood the concept. Now it is easy. Concept is everything. Concept is everything. Perfect. So now let's try to see how we can just build this thing. And just to demonstrate this, we will use an example. And yeah, let's quickly create a clone of this. And let me just say 3 and parallel chains. Perfect. So this cell will remain the same. Let me just run this with this virtual environment. Perfect. Chain with custom runnable. So as you know that this is our first task. If you look at this thing template. So now you will say, obviously we do not have any kind of data for now. We will just discuss those examples as well. But for now, let's say I want to just do this thing, right? So first of all, just for the understanding, we will just use a hypothetical situation, hypothetical example. Then we will just also looking at some real examples as well using data engineering. But first I want you to understand the thing. Okay. So that is why I'm not directly pulling the real world example. You will be like totally off. First, let's start slow, right? And then we're going to just grow. Okay. So now the thing is, the requirement is very simple. This template, what it will do, it will simply ask LLM to summarize a movie, or just ask LLM to write a quick summary about a movie, right? So you are a movie summarizer. Okay. And here I will simply provide the input as please summarize the movie in brief, because we do not want to spend much tokens. And this is the input, or let's say movie name, whatever you want to do. Okay, input. So this is my prompt. Okay, this is task number 1. Perfect. Let me run this. This is my task number 2. Perfect. And this is my task number 3, which is like string output parser, which is like very common. Perfect. Now here comes the thing where we need to create the parallel chain. So let me just remove all of these cells because these are not required at all. Perfect. So now there are two options. Okay. Now there are two options. I will just show you both the options because it's my responsibility to give you all of the knowledge. Option number 1 is to create a dedicated chain for this task. Dedicated chain means like dedicated chain, like it will run 1, 2, 3 and all. Okay, like it will have its own tasks and it will do everything on its own. Creating the chain, dedicated chain. Makes sense. It is very handy, not a big deal. The second option is very simple and it is much more scalable and it is easy to manage as well. What is that option? See, if we have, let's say, just a few tasks, okay, it is easy if we just create a dedicated chain, it's fine. But if we have like multiple tasks, we can even create a function. Okay. Remember, I told you that we can also create a function for the entire chain as well, right? So we can even create the function for the entire chain. Okay. So what I will do so that you can learn both the ways. For chain number 1, I will use the normal chain method. I will create all the tasks for the chain. For chain number 2, I will not create the chain. I will only create one function and I will not hard code basically. I will just write the code for every task. Okay, that way you will learn both the ways. Simple. Okay, let's do it. So first of all, let me just use the method number 1. So I will say markdown parallel chain 1. Perfect. Chain with parallel chains. Perfect. So parallel chain 1, what will be the you can say step number 1, basically task number 1. So I'll simply say task 1, which is obviously prompt, right? Which is obviously prompt, and I will say, and what type of prompt is this? So let's say we have the summary of the movie. What we're gonna do after that? Once we have the summary of the movie, we will ask LLM to create basically a LinkedIn post, right? And in the second chain, we will simply say create an Instagram post, because both the platforms are different. The tone for both the platforms are different. So let's try to do this, okay? And in the real world, what we will be doing, sending an email to manager and sending a Teams message to a director or whatever. Okay. But for the simplicity, I'm just taking an example, like hypothetical example, so that we can quickly learn the thing that we're trying to do. Because once you know how to do it, you can just implement that solution anywhere, right? So let's say I will write prompt, let's say LinkedIn prompt. Perfect. You are a helpful assistant. Not helpful. You are a movie summarizer, or I will say you are a post generator, LinkedIn post generator. Perfect. And I will write this input. Create a post for following text for LinkedIn. Perfect. This is my task number 1. Let me just create task number 2, which is LLM, and task number 3 is this one. Perfect. Makes sense. Simple. This is my chain number 1. Let me just run this. Perfect. 3 things. Perfect. This is my parallel chain number 1. Okay. Now, if you will closely observe, this is, and we have just covered this thing. That's why I covered that topic in detail. This is a kind of template, right? Like not template, like this is a kind of input that depends on template, right? What it needs? It needs a dictionary, right? It needs a dictionary. So what we need to do, we need to add one small step here, custom, you can say task, which will create a dictionary for us. Make sense? That's why I covered that topic in detail, the very previous one. So I will add one task here. I can add it in the parallel chain one, but it will be a redundant task because we would need to do it in both the chains. It's better to just create one task before both the chains, right? So let me just say, and let me just grab that function from here, dictionary maker. Yeah, here, perfect. Task 4, and let me just write it here. Perfect. Custom runnable dictionary generator. Perfect. Let me just run this as well. So now we are good. Perfect. So it will simply generate text and the other thing. And here we have this particular chain which will expect text, right? And we are simply returning the text dictionary. So it needs to be same, exactly same. If it is not same, it will not run fine, because you know the output of one is dependent on the previous one, right? Like the output of one will be the input for the next one. So next one is dependent on the previous output. Okay, I hope it is clear. Perfect. So now it is done. Simple. Now I will be creating parallel chain 2 and just see how I will create that. So for parallel chain 2, so if you just look at this parallel chain 1, I think it is incomplete, right? How? Just let me know in the comments how. Because these are just tasks. We have not created the chain for it. So I will simply say chain LinkedIn equals LinkedIn prompt and LLM OpenAI and string parser. Perfect. So let's run this. Perfect. Now it is a chain. Now, instead of creating chain like this, what I will do you know? I will simply create a function. I will say def insta chain. Okay. And here in this function, I will write all of these three things. Like usually what we do in the function, right? Like normal function. Exactly. That's exactly you need to do. Task 1 prompt. Right? Perfect. And here I will simply say insta prompt. And here I will say Instagram. And here I will say Insta post. And here I will say Insta. By the way, this is not required, so we can just leave it as is. Perfect. So now as you can see that we can define everything in the function. Wow. Literally wow. Because whenever we create function, we have more control. Why? Because I know the output of this will go inside this. If I need to make any changes, I can do it in the function itself. I don't need to depend on like, hey, this will generate the output like this and hey, this will generate the output like this. No, I'm open to do anything. Make sense? So I will get the text like this. Text is of string type. And I think this function will receive a kind of dictionary because we pass a dictionary. And this will generate, yeah, perfect. So text is of dictionary type. Perfect. So now I will simply say text equals text of text, right? Simple dictionary. We are getting this key value and now we are simply passing it here in the text. And now I can invoke it within the function itself. I don't need to go to like wait for it to execute. So I will simply say insta prompt final basically, or like this is one way of doing it, or you can even call the entire chain in the end, like at the end. Like choice is yours. You can even call the entire chain at the end because you know like how to do that. So I'll simply say chain insta and this thing, and you will simply say chain dot invoke, chain insta dot invoke, and it will simply say text, and you will simply return chain insta. Not this one, I would say result, because you just need the result. So this is another way to doing it. So what it will do, it will go to this function, it will create the chain, everything is exactly same. If you just compare the code, everything is same. We are simply creating a function on top of it. It is easy to manage because let's say you want to import this function as a utility, you can do it. It's just like that. And second benefit will be you can make the changes in between, because if you do not write like this, you can simply make some changes here and you are not actually dependent on this particular thing. Make sense? So let's say even if I comment it out, you can run all of these things in the steps, right? And you can just make those changes. And if you create functions like this, you do not need those functions like dictionary maker and all, because you can make the changes inline. Again, it's personal choice, but my agenda is to make you aware of all the possible things. You do not need to stick to everything written in the documentation. You need to be creative as well. You need to know like what are the things we can, who is this? You need to know like how are the things we can do, right? Make sense? So now what are we doing? We are simply invoking it from within the function. Okay. And then we are simply returning the result. And what is result? The string. That's it. Okay. Makes sense. Now we will simply create a Lambda function for it. I will say insta chain runnable equals runnable Lambda insta chain, right? Let me just run this. Perfect. So these two are done. Very good. So now Finally, we need to finalize the final orchestration. That means we need to now arrange task 1, task 2, task 3, task 4, and then these two parallel chains, right? Let's try to do it. Let me just write parallel chain 1, parallel chain 2, and now it will be final orchestration. Perfect. Now final orchestration is very, very important. I will simply say final chain equals, first of all, we have, I think, prompt template. Then we have LLM OpenAI, string parser, dictionary maker runnable, and then we have, let me just use that braces so that I can just show you better. Okay, we have this, we have this, we have this, and then we have this, and then we have parallel chains. Now is the thing, because now we need to create two chains, right? So we have something called as runnable parallel, and let me just first of all import it, and I would need to import it here from Langchain core dot runnables. Import runnable parallel and import runnable lambda. Perfect. Okay. Runnable lambda runnable. So here we will be using a special function called runnable parallel. Make sense? Runnable parallel. Perfect. Now what is this function? This function says, now after this particular task called dictionary maker, you need to create two parallel things. You need to create two parallel things. So what are the things? What are the tasks within that? Now I will define the chains that I have created. One chain is this one, very simple, chain LinkedIn. Very good. I will simply say, I just need to pass a list, basically. Not list. I can also do like one more thing. It's called branches, because there will be like two branches. Let me just show you. So these are the two branches, 1, 2, right? So we have a built-in function as well, like branches. We can just use it. And I think this is a better way to manage it as well, because I will just show you the output as well. So when we say branches, then we can define the branches. Like what are the branches? I will simply say, hey, branch 1, you can name it anything. Okay. Branch 1 is, let's say, LinkedIn. And second branch is Instagram. Okay. So LinkedIn branch is chain LinkedIn. Yes, but for Instagram, we have a function, right? We have a runnable. So I will do this. Make sense? So this is my final chain. Okay, and why it is red? Okay, makes sense. I know why it is red. Because this is missing. Yeah, now it's fine. So let me just invoke it now. Final chain dot invoke. Now just tell me your favorite movie. Because we just need to write the movie name, right? In the first template, we just need to write the movie name. Yes. So let's say I want to write a quick brief about KGF. I love that movie. Who is saying Pushpa? That movie is also good, but KGF is like KGF. By the way, I love Pushpa as well. But KGF is like KGF, right? KGF is KGF. So let me just run this. Let's see what we get, because I want to show you the final output. It will be like very interesting. It is taking time because we have so many steps involved. Let's wait. String output parser, this. Okay, perfect. So it took 25 seconds. Wow. So first of all, what happened? Let me just show you what happened. So if you just look at this thing, first of all, template. We created a template, prompt template for movie KGF. Then we asked LLM, hey, write a brief summary about KGF. Simple. Then we use string output parser to just fetch out the string, and then we used string to create the dictionary, because I know we have these templates, right? So we use those things. Now we need to pass that template to create the Instagram post and LinkedIn post. Make sense? That's what you want to do. So here we can just do this thing with the help of these two chains. This is chain number 1, that is a traditional way to do it. This is chain number 2 with function. Like now you have both the ways. Now you can just do anything. And I have also given you the option that you can even ignore this chain definition, because you can call everything within this function with the changes that you want. That is another way to do it. Make sense? Okay. Now this is the final chain that we have created. Makes sense? Now we invoked it. And if you just looked at the output is not very straightforward. Output is saying that you have branches key, and within that branches you have a dictionary with 2 values, LinkedIn and Instagram. And you know from where I just got these 2 values? From here. Because I defined that I want these 2 branches like this. And this is my LinkedIn post, and this is my Instagram post, like content of it that LLM has generated. Make sense? And see, both are different. Okay. So that's how you build the parallel orchestration. Just a bonus tip, I want to also show you one more thing. It's a very quick one. Let's say you want to highlight, or basically you want to display this thing in a better way, right? So you can even, like this is a final chain, this is a chain in itself. You can also treat this chain as a runnable. Is it possible? Yeah, it is possible. So for example, let's say you want to create a chain like this. Let me just write it here. Chain as a runnable. Okay, chain as a runnable. So let's say once you have this chain, this final chain, now you want to extend this chain, right? Now you want to extend this chain, and you want to now connect, let's say, one more function. And what this function returns, it beautifies the output. Because we have the dictionary here and we do not want to present it like this. We just want to beautify it. So what I will do, I will create a function. I will say task1, right? Task1 will be my beautify function. Okay. I will say df beautify, and I will simply get the output, and output can be, let's say, it is a dictionary. We know that because it will return the dictionary. Again, fundamentals. This output will go as the input to the next function, next task, right? Fundamental thing. So now this is a dictionary. So now we will just create our function accordingly. We cannot just expect anything, any string format. No, we are just treating it as a dictionary. So I'll simply say, let's say, final response, right? And it is of a dictionary type, right? And I also want to return dictionary, but not a dictionary, I would say, yeah, dictionary, but in a better way. Yeah, we can say that. Or let's say text. Let's say I want to return string, let's say. Or let's say dictionary, because these are 2 different things. So usually we should just return dictionary. Best practices. Okay, so I will simply say final response equals to this. I will say LinkedIn response equals to this. Yeah, perfect. So I have created this function, LinkedIn response, Instagram response, and I'm returning this dictionary with a beautified version. Makes sense? And now obviously I need to create a runnable for it, and you already know how to create that. So I'll simply say beautify runnable equals to runnable lambda. Perfect. Now this is done. This is like task number 1. Now if for the task number 2, final chain, you already know that I have a final chain. So I'll simply say final chain equals final chain, like whatever we have here. Perfect, like this. This is the final chain, right? Yeah. So what I will do, I will create the runnable lambda for this. Like I have 2 options. I can even simply write final chain like this. Like if I write like, because chains are also runnables by default, if you do not know this. I know this is confusing, but this is important. See, I have 2 options. I can only tell you just scratching the surface level things, or I can just make you understand the things while going deeper. So I will just prefer the second option. So I know it is like confusing, but it is good for your growth, and I know you are uncomfortable. That's where you grow, right? Okay. So I'm with you. Don't worry. I know it is confusing, but it is fine. So let me just tell you. So let's say, let me just take you to the diagram. So let's say this is the final chain, right? This is the final chain that we have built. Let me just move it a little bit up. Perfect. So let's say this is the chain that we have built. Perfect. Now this entire chain is a runnable. Okay. It is a runnable. This is the nature of it. Make sense? So that means you can just use this entire chain as your runnable and you can connect it to the next task. So let's say you have this task, right? And you want to now connect it using a normal edges. You can do it. It's not a big deal. Which is, let's say, beautify. I hope it is clear. So it is the property of it. Whatever we create in the chain, it is a runnable by default. So I can literally write, now my final chain is like final chain, as you all know. Okay. So now I will simply say final chain. Okay. And I can comment it out because we do not need to recreate it because it is created here. Now I will simply say beautified chain. Beautified chain. And now if I simply create, let's say beautified chain equals to final chain and then beautify runnable. See, now I can literally use the entire chain as my runnable. So it is a by default behavior. You need to understand this. Yes, you need to explicitly convert your Python function as a runnable, but if you're creating a chain, you don't need to convert it into runnable. That is a runnable by default. Perfect. Now let's try to run this. Beautiful beautified chain dot invoke, and this time let's say Pushpa. Let's see. What do we get? It will, I think, take 10 more seconds. And I hope now this will give you a richer understanding about managing the chains, because it is very easy to just show you, wow, we have an error. Wow. What is error? LinkedIn. Output is truncated LinkedIn. Okay. So it is saying error is at LinkedIn. Here we have LinkedIn. Oh, I see. Basic mistake. So now we have final response in the form of dictionary, right? Do we have LinkedIn key available? No. The parent key is branches. Inside the branches we have LinkedIn. So I will simply first of all add the parent key, which is branches. And then we have Instagram or LinkedIn, whatever. Make sense? Make sense. Let's use single quotes. Perfect. Now let's run this. Yeah. So I was saying that this will give you a richer understanding, because it is very easy to build those simple chains, okay, where I will simply show you, hey, this is prompt, this is LLM, this is string out parser, wow, that's it. No. You are becoming a good developer here, and you need to understand all of those things which are complex. Make sense? Pushpa is taking more time. Why? KGF took just 25 seconds. Wow, we have fire. So as you know, now we have the beautified version, right? Now I can literally use these two key value pairs to perform my thing. Let's say email and Teams message, whatever. But we took just hypothetical situation just for fun, so that you can just enjoy while learning it. But you know, like, you can literally apply this thing anywhere. And don't worry, I will just show you one quick example as well, even if we do not have any kind of real data, but we can just show you. Make sense? Okay, let's see. So now let's talk about the conditional chains. Now, what are these conditional chains? So now we know like how parallel chains run in parallel, But now every time we do not want to just run everything in parallel. Now, if you just look at the example above, it is exactly the same, right? Right? It is exactly the same. But now the difference is this is a conditional chain. That means both of these chains will not run. This chain will run if the condition is yes. This chain will run if the condition is no. So that means we can even create conditional chains as well. And again, in the real world examples or in the real world scenarios, we use conditional chains as well, because you do not need to run everything. You need to keep so many things autonomous so that you can decide. And that is the entire, I would say, backbone of autonomous agents, autonomous workflows. Autonomous are nothing but just fancy if-else statements, and that's it. Because there is something which is actually evaluating the decision. In simple terms, it is simple if-else condition. Okay, great. So now let's see how we can just implement this thing. And architecture wise, it is very clear. So now I'm not just explaining this from scratch because you know all of these things. Now only thing is how we can just create these conditional branches, right? So let's go to our anti-gravity and now let's create conditional chains. Parallel chains, and we can just call it as conditional chains. Very good. Now the flow will be very simple and very similar as well. So what we're going to do, we will simply ask for the movie summary, and before that what I will do, I will write the review. What does it mean? Let me show you. So first of all, this is the prompt template, right? We do not need to now write the summary. No, because we want to just evaluate the response. So let's say you are actually building a pipeline, okay? And you need to automate this particular AI workflow as a data engineer. So let's say you're a product-based company. If you're not working in a product-based company, don't worry, you will be working in a product-based company very soon. Don't worry at all. So let's say you're working in a product-based company and your company is selling some products, right? And you are assigned a task where you need to automate their customer reviews. What does it mean? So basically, let's say there's a product and there's a customer XYZ wrote something, hey, what is this product, shit product, blah, 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 blah. So in that particular scenario, you do not need to build your NLP or basically natural language processing machine learning model to categorize it. You can leverage LLM. That's why you are an AI data engineer, right? You do not need to involve an ML engineer. You as a data engineer can do it. So now what you will do, you will take the review, right? And you will pass it to the LLM. Make sense? And that LLM will actually categorize it whether the review is positive or negative. Okay, how LLM can do that? LLMs are actually the NLP models, okay, behind the scenes, built on top of the transformer model. So they are well trained on these kind of tasks. Really, yeah. They are very well organized, very well like trained on these types of tasks like categorization, and you can say if you want to evaluate something, LLM can do that very well. Because it is trained on such a large corpus of data, I cannot even tell, like such a large corpus of data. So it can evaluate these things very nicely. Usually we do it with the help of BERT models as well, basically encoder only models, but it is not very performant. That's why we use LLM. That means like transformer based models. So LLM can do that very well. Okay, but yes, we need to guide it. We need to also use a structured output that you learned in the beginning, Pydantic, because LLM, yes, can do that work, but LLM will not just say yes or no. You need to guide LLM, bro, only respond as yes or no. Do not say this person has said that. You need to just say yes or no, and you will be doing it with the help of Pydantic. Make sense? Okay. So now your fundamentals are strong enough to build those things. So let's try to write this thing. You are a movie reviewer or review. You are a movie review evaluator. Make sense? And then I will say, please categorize the movie review as positive or negative. Simple. So this is my prompt. But before building this prompt, I will build my Pydantic class, if you remember. So I will simply say from Pydantic, import base model, and I will simply say class, and let's say LLM schema base model, and let's say movie summary flag. Okay, and I will use something called as literal yes or no. Okay, or let's say positive or negative, positive and negative. And let me just import literal as well. From typing, import literal. So this is my schema, because I just want literal means like you just have these two options, either positive or negative. You cannot answer anything else. So I will just use this particular schema to build my LLM. So how I can just do that? I will simply say LLM structured output equals LLM OpenAI dot with structured output and LLM schema. Perfect. So now this LLM knows that it needs to generate the response in the form of this thing, positive or negative, and that's it. Make sense? Make sense? Okay. Okay, makes sense. And obviously, I can just test it as well. Let's see what it returns. Dict must be a prompt value. What is this? Okay, makes sense, because we do not have like any kind of input, but okay, makes sense. So I can simply say like this. Okay, see, now it has done just this. Movie summary flag equals to positive. Very good. Now, do you know what? Now you will say, Ansh Lamba, we need to use this particular thing in our downstream models as well. But this is a Pydantic object. How we can just parse it? You have two options. You can either create your own custom function, custom runnable to use it, or there's one thing as well provided by Langchain. It's called Pydantic output parser. What Pydantic output parser will do? Pydantic output parser will simply parse it. Okay, let me show you. So if I say demo chain, okay, this is just a demo chain, and I will simply say LLM structured output, and I will say Pydantic output parser, and I need to define the schema, and schema is LLM schema, right? And now if I say this thing, now let's see what we get. Pydantic output parser is not defined because we didn't run this. Now let's see. Okay, what's wrong with this? Okay, I think this is fine, because by default it should take the pattern. Let me just specify this Pydantic object. I think so, because this is the code. Oh, this time the error is different. Okay, this time it says validation. Okay, validation error makes sense. That means it is running fine. Okay, this is running fine. So now this is a good thing. So now do you know what happened? This has actually thrown one error which is called validation error. That means it's saying, hey, validate. See, if I am just running it without this, okay, if I'm just running it without this, so what do we get? If I just comment it out, let's say like this, what do we get? We simply get LLM schema movie summary flag equals to positive. Okay, makes sense. So it is just returning like this. Okay, so now if I'm just adding this particular thing, which is this one, it is throwing the validation error. That means it is saying the validation is not right. And what is the error? Let's read it. Input should be a valid string, type equals string type, input valid equals to LLM schema, this thing, input type equals to LLM schema. For further information, visit this. So it is saying like it is a kind of validation issue, and you cannot do it like this. So in order to solve this, you actually just need to remove this. Why? Because you do not need to do this. Why? Because you are already converting the text into a Pydantic model. If you see the response, it is already there. If your LLM would be just generating the dictionary but not a Pydantic, then you would have used the Pydantic output parser. That's the advantage you get when you use the premium models, which are hosted by reputed tech companies, because they understand everything and you do not need to do anything. So that makes sense. So this thing is ready, and we know that this will generate a kind of you can say Pydantic object, right? And that's it. That's what you want. So now what we need to do, we will simply use it. And how we can just use it? So let's say this is our LLM structured output. Let me just rerun this. So let's make sure everything is fine. So this is done. Okay. So now we have this particular LLM created, and now we can simply say chain with conditional chains. Perfect. So this is the kind of prompt that we are using. You are a review evaluator. Please categorize the movie review as positive or negative. And this is the input. I will just pass the input in the runtime. Perfect. And this is the task 2, which is this one. Perfect. And I can run this as well. Perfect. Now I do not need to create this string output parser because we have Pydantic. So that is fine. We need to use this to convert the Pydantic object into a kind of dictionary, you can say, because we will be receiving the object, Pydantic object, right? And in order to create the further conditionals, we need to just use a kind of custom function. So I'll simply say Pydantic JSON, because I want JSON. So this will give me a kind of, you can say, Pydantic object, right? This will give me the Pydantic object. So now how I can just convert this Pydantic object into the form of this thing. So what I will do, I will simply say input, right? And this will be of LLM schema type. Make sense? Because this is a schema. This is not string. This is not integer. This is not list. This is a different schema. And I will return a string. Perfect. Now let's try to do it. How we can just do that. So I'll simply say input dot model dump. That is the, you can say, modern way to do that, because if you will see the result of this, let's say I want to invoke this model. I will say result equals LLM structured output dot invoke. Let's say this movie is good. Okay. And if I write result, so this is a schema. If I say model dump, then do you know what? You will see the dictionary. This is a function that we use, especially with the Pydantic objects. So I simply need to say model dump. And if I just want to get the movie summary flag, I will use it like this. Movie summary flag. Perfect. So these are the best practices that you use. Okay. So you just need to get this thing, model dump JSON, and I can delete this cell. This is not required. And we can just do it here. Perfect. I will simply say input dot model dump, and we can return this thing. Perfect. Nothing fancy. Yeah. And then we can just simply create the runnable lambda, and that's it. Pydantic JSON lambda to runnable lambda. Perfect. So these are my tasks that I have created. 1, 2, 3. And once we have this thing, then we will be creating 2 chains, like whatever you want to do. We will simply say parallel chain 1, and you say you are a LinkedIn post generator, create a post for the following text. For let's say we want to just post it on LinkedIn, like whether the comment was positive or negative. It's just a hypothetical situation. But in the real world, what you will do, you will simply categorize it, and you will simply revert to that email back saying, okay, this movie was good, thanks for your feedback. If the person says movie is bad, you will simply say apologies for that, and I hope blah blah blah, whatever you want to say. But here we already have the code written, so I don't want to write the code again, and we can just reuse it. Make sense? So let's say you want to use this parallel chain 1, which is chain LinkedIn, and we want to use this because it will just simply return positive or negative. So it will simply generate the code, you can say prompt for positive, okay, and it will generate the post for just positive word. That's fine. Makes sense. And it will do it here as well. Perfect. So now let's come to the final orchestration. Remember that we created this runnable parallel. Yeah, we created this. And you know what? Here we have something called as runnable branch. Yes, runnable branch. So what we do here, we simply need to create a kind of conditional chain. Okay, conditional chain. Like we'll simply start with the normal orchestration. Let me just show you. So first of all, let me just create a conditional chain. Now this conditional chain will be runnable branch, and obviously we need to import it. Runnable branch. Perfect. So now in this runnable branch, I will define all the things, all the conditional branches, so first condition is what? First condition is this one. So I will simply write condition. Okay, you can also name it, it's your choice, but usually we simply write a function directly, because just tell me one thing, we want to go to this chain. If the answer is yes, so we obviously need to define that particular function. Okay, so we'll be using the lambda function. So I will say lambda x. Okay, lambda x, and then I will say positive in, or let's say positive in x. Make sense? If that is the scenario, if lambda is there, then simply you need to run my function, which is the chain LinkedIn. Let's say if positive, we want to run the LinkedIn chain, otherwise you can say chain LinkedIn, and we can also run chain insta. Insta chain runnable. Perfect. Instagram, not Instagram, Insta chain runnable. Make sense? So these are the two conditions that I have created. If this is true, then this, and otherwise it will be like this. Make sense? And then default, we can simply say chain default. We do not have any kind of chain default, so we will simply leave it as this. So this is my conditional chain. Runnable default, but must be. Oh man, what is this? So we can simply say default is this one, because we just have to. So I will simply say default equals, like you can just say default equals, or you can just simply write it like normal chain. Let's say chain Instagram. Insta chain runnable. Perfect. Now what do you want? Got an unexpected. Yeah, I didn't pass this thing. This auto suggestion passed this thing. Okay, so now this is my conditional chain. So now we can simply create our final orchestration, and it will look like this. Final orchestrator equals, first of all, we need to write this, all of these things, right? This insta chain runnable and blah, 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 right? And this is not parallel chain. We will simply say conditional chain. Perfect. And here it will become conditional chain 2. So from where we are starting our chain? From where? Obviously, we started our chain with this prompt template, then LLM structure output, right? Then Pydantic JSON. So let's write it. And I don't know why this model, this anti-gravity model is not picking right context. Super high premium code editors, see in front of you. So final orchestrator equals, and we can simply define it, prompt template, and then conditional chain. What? Idiot. LM structured output, and then we have that condition, that Pydantic JSON function, Pydantic JSON lambda, and then we have conditional chain. Make sense? Let's run this and let's try to run this. And what do I need to do? I simply need to pass the input. And input, how does it look like? I think we have the input as input. Okay, so let's try to give the input, and input will be I love this movie, or let's say this KGF movie. Wow. Now let's see what it does. We should see like two things. No, not two things, like just one thing. Positive. Perfect. So it has written the LinkedIn post for positive. Why? Because it actually evaluated our, you can say, prompt, whatever we have given, as positive. Make sense? and you know how. I know this was like a little bit complex, but that's how you grow, that's how you learn. And I hope now you have a clear understanding of all the branches, all the things and everything. Now let's jump on to the next chapter. And this chapter is my personal favorite as well, because this is very, very special. In this, we will be covering, first of all, yes, finally, React Agent intro. Perfect. So now you would have heard about this word, this keyword, whatever you want to say. It's called React. Let's talk about it, because it is one of the most popular keyword, one of the most popular jargon we use in the agentic AI and AI data engineering world. It is called React. Now this word is not React. Bro, this is React. See, this is not like React. This is ReAct. What does it mean? React is actually made up of two words: reasoning and then acting. Reasoning plus acting. Basically, it is reasoning plus evaluation plus acting, or reasoning plus observation plus acting, but this is the high level definition. So let me show you React Agent. React Agent full form. Yeah, reasoning plus acting. Yeah, that's it. Like that is the, you can say, core of everything. Reasoning plus acting. There's a middle thing as well, which is called evaluation or observation, but I will just explain you everything step by step. Now just sit back and relax, because you need to enjoy this thing, because this is very important. Because once you understand the React architecture, boom, you understood almost everything. Really, yes. You would have already understood so many things, but this is amazing. This is the hottest part of the entire thing, React. So let's say you want to build an agent. Okay, let's say you want to build an agent. Okay, let's build an agent. Let's say you want to build a React agent, because everyone is just trying to say, I want to build React agent, I want to build React agent, I want to build React agent. Now, how to build React agent? Why to build React agent? So we know that React means reasoning plus acting. Okay. Now, do you know what? What does it mean? Let's say there is Rahul. Bro, come here. So let's say this is Rahul. This Rahul wants to build an agent. Okay. So that whenever there is a user who sends the input, that's what users do, right? Input. Okay. Makes sense. This user will send the input. Okay. Yes. Now, do you know what? Now, currently we are using really high level and advanced agents, LLMs, provided by Openai, which are amazing, which are actually answering all of those things that it knows, right? But there are some questions that LLM does not know. Oh, really, Ansh Lamba. What are those questions? LLM knows everything. Let me show you. If I ask LLM this question, let me just bring the code. Conditional chains, and this is my code. So let me just ask this simple question. LLM OpenAI, which is the best model, one of the best models that we have in the market. Okay. Dot invoke. I will say, hey, what's my name? Simple question. Let me just run this. Let's see what it says. I do not know your name. Would you like me to call you? If you want, tell me now. I will use it for this chat. Simple. So it does not know my name. I don't know why, but yeah, it doesn't know my name. So what does it mean? That means LLMs are not trained on your personal data. LLMs are not trained on your organization's data. LLMs are not trained on data that it doesn't have access to. Only you have access. So what to do in that scenario? For example, let's say you have a database, you have a data warehouse in your organization, and you want to talk to that database. You want to just, let's say, make some API calls, right? Let's say you want to just, you have a Postgres database, and you can just use psychopg library to connect to it, and you just want to grab the data as a result. Or let's say you have data warehouse and AWS and Azure, you can use the API calls to get the data. Make sense? Like, you can just do that. And you know how to build those Python functions. Yes. But how LLM will do that? Because LLM doesn't have access to do that. And how it will do? Then in that scenario, we simply create something called as tools. What do we create? Tools. So let's say we have some tools. Let's say we have a tool for our Postgres. Let's say, right? Or let me just use Postgres. Perfect. So I have this function, Postgres database, that can access this Postgres. Okay. Then let's say I also have access to email, right? Because obviously LLM cannot send an email to me. Let me show you. If I say send an email to Ansh Lamba blah blah .com. Yeah, @gmail.com. Right? Let me just write this. Is it actually sending an email? See, I can't send email directly, but I can draft you one copy. See, it cannot send the actual email. It cannot. So what does it mean? That means it doesn't have the capability to send an email. Let's say it also wants to do something with your, let's say, code. It doesn't have access to do that. It can answer your questions, but it doesn't have the capability to perform these things. Then who can perform these things? Who has the access and who has the capability to do all of these things? You. Okay. So should we become LLM now? No, not really. I didn't say that. No, we do not need to become an LLM. Now you need to create the tools. You need to create the functions for these things. One function for this. One function for this. One function for this. Okay. Okay. These are our functions. Okay. These are our functions. Perfect. Perfect. And you will create something called as tools, or basically toolkit. These are tools. Tools are what? Functions, right? So when I combine all of these things, what it will become? Toolkit, right? This is my toolkit, where we have all the tools written. This is my toolkit. Make sense? Anything fancy we have discussed? Nothing. So simple. So simple. Perfect. So now I have this toolkit. Do you know what will happen now? This LLM will connect to this toolkit. Okay. To this toolkit, and it can make use of these functions. Really? Yes. It can talk to these tools in the backend. Wow. Now what we did, we actually increased the power of our LLM. And this step is called tool binding. This is what? Tool binding. We basically bind our LLM with the tools. That's why it is called tool binding. Okay. Okay. Makes sense. Tool binding, right? Do you know what will happen now? Now my input, if this input can be answered directly by LLM, it will simply give the response. Take it like this. It will simply say, hey, you want the response? Okay, let me just give you the response, and this is the response. Take it like this. Simple, right? But when this LLM doesn't have this capability to do that work, it will look for its tools. It will look for its toolkit. It will search for the relevant tool. Hey, let me just check. Do I have that tool to perform that action? this user has asked me to send an email. Do I have the tool? Let me just first of all check it. It will simply search for that particular toolkit, right? It will search for that toolkit. Now that tool from that toolkit will be used if that can do the work. Let's say this email tool is there. So what will happen? It will simply go to its toolkit. Okay, go to its toolkit to search for the tool. Let's say this toolkit has got the response. Now do you know what will happen? This tool will not send the answer directly back to the user. No. This will give the response back to the React agent. Okay, like this. This will be a loop. So what did I say? This React agent will search for the tool. It will make the use of the tool. The output of that tool will go back to the LLM. Basically the React agent that we are building. Under the hood, it is just an LLM, right? So this will go back to the LLM. It will observe it. Hey, this tool has generated this output. Is it good enough to go ahead, or should I just make another tool call? Let's say this email tool has done the work and has not actually completed the work. It needs to make another tool call. It will again go back to the toolkit and will search for the task that it's pending. Then it will bring that tool, and then it will just give the response back, and then it will just observe it. This step is called evaluation. This step is called basically you can say reasoning, or basically observation. So that is why it is reasoning plus acting. That means it will first of all call it, it will take action, then it will just do the reasoning part as well. It will also observe the output. Once LLM is satisfied that I have the final answer, only then it will generate the output. Only then. And if it is not satisfied with the output, it will not generate the output, and it will keep on searching for the tools. Yes, that is the entire concept of React. And this is a kind of agent that everyone tries to build nowadays, because this is a kind of autonomous agent. Because you have the tools, you just create a wide range of tools, or let's say long list of tools, and your React agent can actually do everything. But you need to understand all the ins and outs of this thing, because this is not very easy to understand it. Let me be very honest. Yes, I will show you the code to implement this thing first of all, so that you can actually see what is going on, how the things are going. Then I will be breaking down each and everything, like how it is doing everything behind the scenes. Because in Langchain, you do not see behind the scenes. No, you do not see it. If you know the things in detail, in depth, then obviously you can just see it. By default, it will not tell you how it is doing that. I will just show you how it does that behind the scenes, and why it is very useful, because then you can just customize this agent as well for your own use case. And again, for the interviews, it is like very, very, very handy, very superful, very helpful. I hope it makes sense. I will also show you tool binding. I will also show you how it is working. Makes sense? Okay, let's see. First of all, the code implementation, which is given in the documentation as well, which is the first step. Then we're gonna deep. Okay. So now let's just try to write the code, and I can also show you the documentation. Let's see. React Agent Langchain. And you know what? There are so many tools available in the Langchain as well. So you do not need to create tools from scratch. There are tools such as Wikipedia search. There are tools such as called DuckDuckGo search. If you just want to search for news, latest news, there are so many search. There is like Tavily search, which from which you can just make some search. Like you can just use Tavily as a search engine. So there are so many integrated tools as well. I will be using 2 to 3, and then you can just explore and learn. Okay. React Agent Langchain. Okay, where is that documentation? I think documentation, let's try to explore on our own. Langchain and agents, maybe here. Okay, so here they have just updated this thing. Earlier it was called as create React Agent, but now they have just created a new function, new class, whatever, from langchain.agents import create React Agent. So now you just create like this, create agent and tools. See, simple. Did you understand that? You simply need to define the model that you want to use, and you want to just add the tools that you want to attach to the LLM. That's it. And everything will be done on its own. See, simple. But yes, you need to create the tools on your own. And obviously, you need to define the tools, how LLM would know like what tools it needs to just use or create, right? And there are some dynamic models as well, which I'm not a big fan of it, because if you just want to make a tweak, I would rather stick with my own code to make some tweaks instead of using their decorators, because they can just make changes to their code base anytime and they will simply say, hey, we have a new update available, we have this v1 available, and yes, your code base will be broken. I cannot just make my own decorators, bro. You do not need your decorators. So that's why I do not use these decorators and all. If I want to make any tweaks, if I just want to make my agent dynamic, I will just write my own code and I will just make it. And yeah, that's me. Okay, so let's try to see what are the tools. Let me just click on tools, and here are the tools that we have. And yes, we can use a tool decorator. This is something which is stable. We can just use this. Okay. And yeah, it's I like using this tool definition. And there are so many tools. First of all, I just told you that you can create your own customized tool. So this is the definition for that. If let's say you want to sort something within your database, right, and you can just simply do it. If you want to use integrated tools, let me just see if they can just show you the integrated tools. Integrated tools, no, they have not shown here. I can just search. Let me first of all close all these tabs. So I will simply say DuckDuckGo search Langchain, because that is like one of the tools. See, so here we have, oh yeah, I think they have just moved the thing to integrations. Perfect. So if I just go to integrations, I will see all of these tools. See, popular providers. I have tool for Openai, Google, Anthropic, AWS, Google, Hugging Face, Chroma, Pinecone. These are by the way vector databases, and Databricks and Mistral. All of these things are here. Redis, Elasticsearch, and all providers. Like we have everything here. These are the, you can say, the ones which are validated, and there are some community providers as well. If I just open this one, I will see a long list of all the things. See all providers, click here, and then you will see all of the providers here. See, wow, such a big list of tools that you can just create. These are all of the, you can say, tool integrations, whatever they have created. DuckDuckGo search, DuckDB, like so many things. 11 labs, wow. So you have so many things. So let's try to start with anything. We can also use IBM, Jaguar, wow. So many things. Wow, man. They have actually added so many things. You can also explore on your own. See, Tevily is also there. Tevily is basically the search engine that is very popular. And then we have, wow, so many things. We have Twitter as well. Wow. So now let's try to apply this thing. React intro. Okay. So this is our import thing. Perfect. So now what we're gonna do, first of all, we will create our tools, right? Let's create our tools because that is the base. Okay. Let's create our tools. And don't worry, we will be just creating some amazing tools. Okay. So first of all, let's create the tool number 1. And this will be like, say, news search, because let's say your user wants to get some news, right? So we can just have that tool. And what is the basis of the news search tool? It is called DuckDuckGo search. And I can just show you DuckDuckGo search. It's here. So if you want to use DuckDuckGo search, it is free. That's the best thing. You do not even need any kind of API key, because with some other search news search tools, you need some API keys, but it is completely free. So how we can just use this tool? This is first of all very well integrated. DuckDuckGo search is actually a standalone you can say service that you can just go to their website and you can just see how you can just use it as an API, as a you can say as a Python function, as a Python API. But you do not need to do this, because even if you write this, let's say Python, so you will get the code like how to make an API call using PyPy, and then you can just see this. But with Langchain, you do not actually need to. You do not need to even install this. You actually do not even need to install this, and you do not need to even write this Python function like this, because that's how you just make API calls, right? Because we are simply making the API calls to the function. But here we have Langchain integration, and we can simply use this function DuckDuckGo search run, which is created by Langchain. Okay, so what I will do, I will simply copy this, and I can simply go here from Langchain community.tools, import DuckDuckGo search run, and this is an instance for that. Okay, let's say search tool, it makes more sense. And I'll simply say Obama's first name. So what it will do, it will make that tool call, or let's say I want to search the news. Who is Ansh Lamba? Let's see if it knows. Search no module in Langchain community. Yes, we need to install this module, which is called Langchain community. So I will say this one. Do we have virtual environment enabled? I think they should add this feature where you can automatically enable the virtual environment. Why I'm writing this again and again? Activate, activate, activate. UV add, and then Langchain community. Perfect. Now let's wait. Perfect. So now let me just rerun this. TDDAX Python, please install the pip install UDDDAX. What do you mean? Could not import DDGS Python package. Please install it with. Okay, there would be something, maybe DuckDuckGo search. So I will simply say UV pip install DDGS. Let's add it as well, because it is saying that. So let's do that. Ooh, it knows, man. Okay, that's good. Good. Okay, so what it has done, this is not generated by AI. This is a tool call. That means I made a tool call to DuckDuckGo search run. Okay, and I simply wrote this thing. Who is Ansh Lamba? Basically a news. I want to get some news, some information regarding this question, who is Ansh Lamba? So this answer is the response of this particular function called DuckDuckGo search run. This is not generated by LLM. Yes, we will bind this tool to LLM so that it can make the use of this function, but currently it is not connected to LLM. This is simply the response we are getting from the DuckDuckGo search run. Make sense? Perfect. Make sense? Simple. Okay, so this is our tool. Let me just hide it. It's fine, because why to show off? So search tool, one tool is done. Let's say I want to add one more tool, and it will be which tool we should use, because we have very long list, and I'm a big fan of this tools list. If you can even go to integration and then tools and toolkits, you will get so much. So you have Google Serper. See, these are the paid ones, these are the free ones. So you can actually compare what you want to use for search, for code, for productivity. You have like so many things: database, finance, integration. And let's try to use one tool for let's say, oh, we have Gmail toolkit as well. Wow, nice. Let's use for Wikipedia. Let's use Wikipedia. Where is Wikipedia? Yeah, here. Let's use Wikipedia. Okay, so what I will do, I will copy this and I will Wikipedia search tool. I will write this, and then I can simply go to this wrapper because we want to run this, and let's write this. So this is like Wikipedia tool. So I can say Wikipedia tool, this is search tool. Make sense? Okay, so now if you just want to test it, the same way we tested is pip install Wikipedia. Okay, let's install Wikipedia. Not a big deal. Perfect. Now let me just run this. Now let me just test it. Wikipedia tool dot invoke. Let's say, what is the capital of France? It should know, right? Because this is Wikipedia. Wikipedia knows everything. Page closed. See, what is this thing? You are actually getting everything, because when you just make a call to Wikipedia tool, you are actually getting the response of the entire Wikipedia, right? So this is that particular thing. That's why you're simply seeing everything. So you are seeing France, but before France, you are also seeing this garbage stuff as well. Close-ended question, contrast with open-minded question. So this is like the response that you get whenever you're visiting the page, the Wikipedia web page, you will see all of these things, right? So that's exactly it is returning. So do not feel bad. That's how it works. That's why we need to connect these things to LLM so that LLM can prune these things, right? Okay, makes sense. So these are the two tools that we have created. Let me also create one custom tool so that you will also learn how to create custom tools. So let's say you want to create one tool which will do something that it can also not do. Like we do not have any kind of integration with that particular function that you want to build, right? So you can build your custom function as well. Tool 3, and I want to make it as custom enterprise tool. Let's say that tool is just for my enterprise, like where let's say you are working, right? So I will simply say from Langchain dot tools import tool. Perfect. Now I will create a decorator tool and then I will write, let's say, enterprise tool. Makes sense. Makes sense. So now what I will do, I will simply create the function, and what this function does, this simply sends an email. We have integrations as well for email. I'm just like demonstrating it with a hypothetical situation where we do not have the, let's say, integration with email, right? So what I will do, I will simply say return and I will say email sent. Let's say email sent. Obviously I need to write the code here to send the email, and for that you would need to create these APIs as well from Mailgun and maybe Gmail API. We are not creating those APIs right now, but you know how to create all those basic stuff like API and then just making the calls. You can just write your code here. Now, very important thing, whenever you are creating your custom function, you need to add a doc string. Why? Legends are asking what is a doc string? Okay, good. Doc string is nothing but a kind of way to add comments in your function. You write it like this, 3 double quotes, and then you simply provide a description. You simply add a kind of message so that LLM can read. Because just tell me one thing, you have created this tool, right? You have created this tool, you are creating this tool. LLM will pick one tool, two tool. It needs to pick that tool on the basis of a, you can say, a kind of message, right? How LLM will decide. How LLM will decide. So in that particular thing, you have to just tell, okay, this is the information. This tool is built for this purpose. This tool is built for this purpose, like this. Okay. So we have to write the description. So that's why I think we can even write description here as well, because that makes sense. Description, I will simply say, this is a tool to search Wikipedia. And I can also write maybe DuckDuckGo search here. Description, this is a tool to search the web for news, let's say. And I can just complete this. This is a tool to send emails to employees. Very good. Email sent. Let me just run this. So that's how we can add the description. Obviously, these are the integrated functions. So we do not have like power to add the doc string within this, but I'm so sure when Langchain would have integrated these functions, it would have already added the doc string, because they know like you are very lazy, you will not write doc strings, but you should always try to add it, right? So now this is the information. Now these are the tools that we have created. Simple. Okay. Now let me just add a toolkit. Basically, let's create a toolkit. Now this is our toolkit. And in this toolkit, we will simply write all the function names that we have. So we have, first of all, search tool, and we have then Wikipedia tool. Perfect. And then we have enterprise tool. See how well this particular IDE is picking the context. It is written here enterprise tool. It is suggesting me email sender tool. Bro, which model are you using in the backend? I want to know. Okay, now enterprise tool. Let me just run this toolkit. So now I have the toolkit of these 3 tools. If I want to see the names of these toolkits, I can also write like this, toolkit dot get tools. I think this was a function. I don't know if it is available now. List as no attribute get tools. I Makes sense, I think, because this is a list. So actually we can actually write like this, toolkit directly. Yeah, so now we have these two, like these tools. Let's say DuckDuckGo search, Wikipedia query run, structured tool, basically name equals to enterprise tool, because this is a kind of tool that we have created. So that is why it is coming like this. Makes sense? So now we have created these toolkits and it looks good. It looks good. Let me just add this code here. So now let's create our agent, because now we're good to go. Perfect. Agent, basically React agent. React agent. Perfect. In order to create the React agent, you already know the code that we have just seen in the documentation. It is very simple, straightforward code, just few lines of code. Earlier it used to be a little bit bigger, but now they have just simplified it. So I can just make some changes. I want to use GPT-5 mini and tools equals to toolkit. Perfect. Now let's try to show you the agent. Now let's run this. Perfect. So this is my agent. Wow. Do you know what? They have just started visualizing this in the V1. It was not available before. We had zero visibility. We had zero visibility of our agent that we were creating before. So now, do you know what is this? This is a kind of mermaid. Mermaid. It is called mermaid code. So whatever it is like doing this thing, we can actually see the backend code as well, but I don't want to show you that code because you will not understand anything in that backend code. No one can understand it. It's basically a way of designing all of these, you can say, DAGs. And in LangGraph, we just can show you as well, and then we can just visualize it as well. Because in the backend, what I have realized after exploring V1, they have literally rewritten everything in LangGraph. I'm so sure, like under the hood, LangGraph is running. I'm so sure, because this kind of thing we built in LangGraph. But yeah, it's fine. So this is our agent. Now you can see that this is the model, right? Because this is the model name. And what is the model? Model is this one. This is the one. We can also say LLM. It's not a big deal. I can also say model equals to LLM. LLM Openai that we have, right? I can even run this. Chat Openai object has no attribute lower. What do you mean? Did we create LLM Openai? Yeah, we have this LLM Openai. Oh, I see. Okay. Makes sense. We have to use this name as this because remember our init chat model thing where we have to define the model itself. So we cannot say LLM Openai like this because this is not the model variable. This is the model itself that they are calling. Okay, that's fine. That's fine. So now this is the model. Okay, and these are the tools. Is it similar to this one? Yes, obviously. Obviously. This is exactly, I know like this looks better, but yeah, this is exactly the same thing. Because this is the model and these are tool calls. This start and end is just a way to tell that this graph is starting and ending. Make sense? This graph is starting and ending. Okay, now I will just show you very good thing. So now let's test this agent that we have built. Now I want to invoke the agent, but I will invoke it using streaming. Now what is streaming? So you are a data engineer, you should know about streaming. Streaming means when we just display or basically use the data as soon as it arrives, right? So when I will be just making this model call, there will be so many things running in the backend, right? In the background. And we want to also visualize this. We also want to see what are the things going on in the background. So we'll be using streaming so that we can see everything what's going on. And it's a good way to actually understand the thing as well. So let me just show you React Agent invoke with streams. Okay, very good. Perfect. So now I can bring that streaming code. It is also written in the documentation, I guess. Where is stream? Wrap tool call. Okay, maybe in the quick start. System prompt. Because I use streaming with LangGraph. I do not use it with LangChain. Okay. Where is that? I saw it somewhere. I saw it. I don't know where, but I saw it. Oh yeah, here it is. It was under SQL database toolkit. Because I know, like I saw it. So let me just copy this and let me just paste it here. So what is this thing? I am simply trying to make a model call. Okay, and I want to write my questions. So what I will do, I will simply say who, or let's say, give me the latest news about, let's say, stock market. That's a good question. So do you know what will happen? Let me just first of all run this. So human message, this is my message. Give me the latest news that I have sent to the AI. Now it will go to the tool call. Just wait. You will see everything. Just wait. It is running in the real time. See. Now again. Let's wait because it is generating more messages. Okay. Tool message. Okay. Oh, more tool messages. Wow. Okay. Let's wait because we just simply posted a very generic message and it is just making more and more tool calls, and now that is done. Now let me just show you what happened. First of all, let me click here scoreable element so that you can see all of the outputs. So first of all, we made a query. Like we asked a query, give me the latest news about stock market. Perfect. This is my message. It went to the model. Yes, simple. Remember the flow. It went to the model, ReAct Agent. Okay, our ReAct Agent that we have created. So now, then what happened? ReAct Agent, basically LLM, didn't have the built-in function to search for the news because LLM is not trained on news, right? Or it cannot be because you need news like latest news, maybe today's news. So now it looked for any tool in its inventory, in its toolkit, and it found a tool. How? Because you provided the description, right? So now we found a tool called DuckDuckGo search. Simple. It used that tool called DuckDuckGo search and it called that tool. And this is the call ID. And these are the arguments. Stock market news January 8, 2026, because today is January 8. See, I'm literally getting today's news. US, S&P, 500 Dow, NASDAQ latest, blah, 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 blah. Then this tool, this AI message didn't generate anything. This tool, basically AI message, generated a tool call and that's it. With arguments. Okay, with arguments. And remember this thing because this concept is really important. You need to understand everything. So AI message means message is coming from LLM. So LLM did not generate a response. It generated a tool call. It generated an indication that I want to make a tool call, bro. Please allow me to make a tool call. Make sense? Then it made a tool call because we have provided those tools. This is the answer that my tool has returned. This is not generated by LLM. This is the message that my tool has returned. Basically, DuckDuckGo search has returned. Perfect. Now it went to AI message again. It got the data. AI message was not satisfied. It made another tool call. It said, give me more news. Now it got this message. Then the AI message said like, give me more data. It gave its query with obviously some changes because it wanted to make some more calls. Then it got the value back from the function. Then AI message again made a tool call and then again tool message gave its the data. Makes sense? And then finally AI message has returned the data, like returned the answer at the end. This is the flow. The point why I'm explaining this thing, because I will just show you the backend as well, like how it is running in the background. LLM never generates the answer. It simply indicates that I want to make a tool call. If it needs to make a tool call, it will make the tool call. It will get the response back and then it will generate the response. If it does not need to make a tool call, it will not do anything. So all of these things are actually managed by Langchain. Actually, everything is managed by Langchain. Under the hood, how it is possible to do it? So basically, under the hood, what do? We simply first of all create an LLM. We bind the tools manually. Here, Langchain has done that part for us. First step, tool binding. Very good. After binding the tools, we make the API call. We basically make the call to model, right? Then we need to define this logic, these two arrows. These are not very simple. We need to build this logic. We will simply say, if in the response we have something called as, let's say, tool call. I will just show you. if it is written make a tool call, then at that time I will call that function. How? Because I have the information for the tool call name, basically call ID, plus its arguments. Because LLM is smart enough to generate the arguments. It will say, bro, you can make this tool call and the tool call will require this argument. I can do that for you, but I cannot make a tool call. You will make the tool call and you will just run the function and you will give me the response back. Who is you? Who? LLM is you. It is talking to himself or herself or itself. Make sense? That's how it works. That's how it works under the hood. Okay. Now if I just show you very good example of like tool calling like under the hood, let me just show you that. If I want to bind my own model, because currently we didn't bind the model, right? Bind the LLM. We didn't bind the LLM. Let me just show you manually binding the LLM. So currently LLM with tools. And once you grab this concept, bro, I would say just go in the industry and build something simple. So manually binding the LLM with tools. So currently if I use my traditional LLM Openai, right? If I say LLM.invoke and if I just ask the same thing, what's the latest news? What's the latest news about the stock market? Maybe it will just give me the news which is like outdated because it was trained like long way back, but it will not do anything. But let's see the result and then I can just continue with that, because I can otherwise give the other prompt for which like it will not have access to do that at all. Maybe send an email or whatever. So let's wait. See, I don't have internet access. Perfect. So it cannot do that, right? Now let me show you the magic. So this is the without binding. Perfect. Now let me just write with binding. Perfect. Now with binding, what will happen? I will simply say LLM bind it, and I will bind my LLM with tools. LLM OpenAI dot bind tools. Perfect. And what are the tools? Basically toolkit. Make sense? Now what will happen? First of all, let me just run this. Perfect. Now if I ask the same question from it, bind it. Let me just ask this question. Let's see what will happen. Perfect. Now do you know what will happen? Like what actually happened? AI message didn't say I can't fetch live news or blah blah blah. It has returned empty content because it didn't generate anything, but just scroll towards right. Just scroll towards right and you will see something called as, scroll towards right. Right. See, tool calls. LLM is saying, yes, I cannot generate anything, but I can make a tool call. So it has listed the tool it wants to use for the tool call, that is called binding the model with the tools. Langchain does it automatically for us, and you will say like how it is doing this. This is the code. This is writing this code for you. Okay, so it uses this thing, and you can also see it has generated the arguments. See, arguments query, because we are using query. You can say input. I can also show you. If I go here in my DuckDuckGo search, where is that DuckDuckGo search? DuckDuckGo search. Okay, so this is like general function, so it knows like it will be a query, so it's fine. And then it is saying stock market news today. It has generated a phrase that it will use. Perfect. Makes sense. And see, it has created multiple instances of it. Now this time again, same tool, but with different argument, because it can have like multiple, you can say those phrases. So earlier it said like latest news today, then S&P 500 today, then it will be like one more, see, Dow Jones Industrial, whatever. So it has actually created 3 different phrases. So it called the model 3 times. And do you know how it happened? You know, it knows this thing. So LLM returned this thing. So let me show you. So LLM returned this tool call, right? Now what we do manually, like Langchain is doing everything for you, but what we do manually, we take this list of tools, because it can have only one tool or it can have like a list of tools as well. We take this list of tools and we make the function call one by one, and we keep on updating that particular response with the message type calls tool message. That's why you are seeing a new type of message called tool message. See, tool message. We do it manually. We do it in LangGraph. But in Langchain, that's why like Langchain is a lightweight, you can say, AI agent builder, because you do not manage it anything. Everything is like done for you from the agentic point of view, not from the branching and all. Branching is like fine with Langchain, but for agentic standpoint. I hope it makes sense. Why I'm putting this much of effort for this topic? Because when I was also learning, I was so confused, and I wish I had this kind of explanation in front of me and in just one video. I would have felt so good, but I'm still so grateful for all the resources that I also got. So it's fine, right? Because every resource is good, because I would say each resource or every resource will teach you something. It will not like give you something which is not useful. It will still give you something useful. So still grateful for all the resources that I have used. So amazing. So now I hope it makes sense, right? Now let's try to build a quick one more example, and it will be like very handy and very useful for data engineers, because I want to build that. It will be fun. So let's end this video with that example, and then I will at the end give you a very important thing to just cover, and it's called RAG. I know you are waiting for that thing. Do not worry. I will also tell you what to cover in RAG and how to cover in RAG, because RAG is actually a totally different area, and you need to go much deeper in RAG as an independent topic. But don't worry, I will just tell you how to cover that as well, because there is a good news. I have a dedicated course on RAG as well. But let's cover this. Let's complete this example first of all. It will hardly take 10 to 15 more minutes, and then we're gonna sum up, and then we can just talk about RAG as well quickly, and then I will just guide you to the best resource for RAG. Simple if you just want to learn from me, obviously. Make sense? Okay. Because RAG is actually different, like totally different as an independent topic. It has nothing to do with any framework. RAG is RAG. Like RAG is totally different. Okay. So let's create second and ReAct DB agent. Let's try to create an agent for our SQL database. Let's try to do this. It will be fun. So now you'll be saying, Ansh Lamba, from where we can just get the database? Bro, Ansh, is this a question? Is this a question? You don't have a database? I know you would have a database, but let's say that database is in the other machine and you do not want to download any server again, and you do not even have a Docker installed. So let's quickly create a lightweight database. It's called SQLite. If you are not familiar with SQLite, it's very simple. SQLite is a kind of serverless database that you can run, and it stores everything within the files, within the storage, and you do not need any kind of server. It is a lightweight database, not like it should not be good for scaling, and it's just for POC, and we are good with that. So let's create a file to init database, right? And for that I would need to install SQLite if it is not installed already. SQLite was not found. What do you mean? In package registry depends on SQLite. What is this? Python version is this. Solution failed for other Python versions supported by project. While the active Python version is 3.12. Okay. The resolution failed for other Python versions supported by this. Project supported Python. If you want to add Python regardless, failed resolution, provide the frozen flag. Why do I need to provide frozen flag? Let me just import it. SQLite 3. It has given me the whole code. Let me just comment it out, everything. Let me just run only this thing, import thing. Let's see if it is working fine or not. Yeah, it is working fine. Okay. We do not need your import. I think it would have already imported it. So, okay, perfect. That's good. That is good. So now what we need to do, we will create a database. So in order to create a SQLite database, it is very simple to create a database. If you have the database here in the folder, it can connect to it, and currently we do not have, so it will create the database for us as well. So let's create it. And yeah, so I'll simply say connection equals SQLite3 dot connect. And if you are familiar with PyMySQL or psychopg2, it is exactly the same. So in that thing, we simply write psychopg2 dot connect, and then we just pass all the thing, host, db, whatever, password and all. Same with PyMySQL, it is SQLite3 dot connect. So now you will say how to connect with this, because we do not have any database, we do not have any password, we don't have anything. So it is called the location of database, where our database is located. It is located in the current directory. So I'll simply say, I will say mydb, okay, mydb, or let's say sales db, just to make it more professional, sales db, and then I want to store it inside, let's say orders dot, or let's say sales dot database, sales dot db. Perfect. And let's create a folder called sales db in the chapter 3, sales db bd. Okay, perfect. So let me just run this. And so what it will do, let me show you. So it will throw the error. Wow. What's wrong with you, bro? Unable to open database file. Are you serious? So you need to create this, right? SQL3.connect sales db. Is the spelling right? Yes. Okay, sales db. I think I know the issue. Like, there's no issue. So currently this file is running from this folder, Langchain tutorial, and we want to run this from this folder. So I will simply say cd. And I can also add the system path from here. It's not a big deal. So I can also say import os, and then os.make directory if it is there, but we already have the folder. So we can also say system.os.sys, or let me just import sys as well. Import sys, and once we have the sys, we can simply add it to the system path. So now what will happen? Now it will add our, you can say, system path to this directory. So now let's try to run it. If not, we can just run it from here. Unable to, it should add it. Os system.path. Let me just print it first of all. Like, what is the directory? Print this thing. Okay, Langchain tutorial chapter 3 init.py. That makes sense. Okay, so it is just returning the same thing. Let me just try running it from the cd, because I know it happens whenever we just use or run this thing via this debug button, because this is not the good way to run the Python file. We should always run like run Python, something like that. So let me just remove it or keep it. It doesn't make any sense. So let me just say cd, and then chapter 3, and then we want to go inside sales db, not sales db. I think chapter 3 is fine. Now if I say python init db.py, perfect. Now if I check the sales db, it would have created the sales.dbc. Perfect, because it creates the sales.db automatically. Makes sense. If I write con equals to this, and if I just run python, it will create this. See, sales.db. I know this database is empty for now, but database is created. Simple. And now I can just rerun this cell as many times as we can, because this will not throw any error. This will not. Why? Because file is there. Oh, okay. Makes sense. Because now, like, it usually either creates the database if it doesn't exist, and if it exists, it simply connects to it. So let's create a cursor quickly. Cursor equals con.cursor. And here I can simply say con.cursor, which is this one, connection is this one. And now I can create a table quickly. And I will simply say cursor.execute, create table, ID, customer name, product name, quantity, price, total. Perfect. I want to create this table. And I also want to say cursor.execute, and let's insert some data. Insert into orders, and values will be this. Just write the values as well, bro. Bro, you can just do this thing as well, or you can just run a loop, but for now we are simply running it for the demo purpose. So let's run it like this. Okay, this is one way of doing it. You can also say with or not open, basically cursor as like cursor, and then you can just simply use the context manager to do it. Like there's multiple ways to do that. I personally like this thing, cursor.execute. If you just want to use context manager, you can just do that as well, like this, with cursor as cursor and cursor.execute. What is the benefit of it? All the things will be done within this context. It is called context manager. Okay, I can even run this as well, like this. So the moment we are writing anything outside this, the context is over. We do not need to worry about anything. Make sense? Okay, so now let's say, let me just make it here. Okay, with is here, and I can say cursor dot commit and connection dot close. Okay, so now let me just run this again. Cursor object does not support the context manager pro. Oh man, this doesn't support because this is SQLite. Because I have used it with Postgres and MySQL, it works fine, but SQLite doesn't support it because SQLite is like very lightweight. So let me just remove it and just follow that traditional approach. So nothing to do with it. So what you can do with it if it is not allowed. So let me just run it now. Okay, it has run it successfully. Now this sales.db has some data. Now we'll say, how do we know? I can just show you. I can just simply create a demo file just for you. I will simply say demo.py, and I will simply say import SQLite 3. I will create a connection with this one, and I will say select asterisk from orders, and let's see what does it return. Okay, let me just show you, bro. Perfect. And this one, do we have any kind of opened that thing? No. Oh man, let me write cd. Wow, it is saying no, this thing is existed. Oh man, let me just open the new terminal. Amazing product, man. Amazing product. So I will simply say python demo.py. Perfect. Object does not support the context manager pro. Okay, we forgot, bro. Perfect. Let me just run this. Perfect. See, I can see the data. That means data is there. Wow. That's how we retrieve the data. So now we have database ready. Your tension, your stress is over now because I have created the database for you. You do not need to download any server. So we have this database ready. Now what we are trying to do here, we want to create an agent which will take care of our SQL things. Can we do that? Yes. It will automatically run everything and it will give the, you can say data to us. So as you can see, we have 3 records. 1, 2, 3, because we ran it I think 2 times, so that's why it is returning like this. Let me just clear it and let me just run it just to see the response. We have 3 response. Okay, so we have laptop, tablet and smartphone, right? So maybe I just want to check the order for tablet, right? Maybe I want to check it, or maybe I want to just check how many sales we made for smartphone. I want to just see. You are creating an agent for any manager and you are a data engineer, you have created this particular data warehouse. Now you need to build an AI agent as well for your database, right? So now what you will do, you will create a SQL agent, and you can build SQL agent so easily with Langchain. Literally, man, you do not need to run any kind of those things. It will already like run everything on your sandbox, and it is very good. Let me show you. If I can just find that documentation, this is the one, SQL database toolkit. So they have created this special tool for SQL workloads. But yes, you need to be very, very cautious to implement it in production, because you need to add some guardrails so that no one can inject some queries which can harm your database and all. So you need to take care of those things, and it is a kind of common sense. You need to do that. But let's say we are good with that, and let's actually try to build this. Okay, so our DB is done. So first of all, I can just create this DB. What is this DB? This DB is nothing but a kind of, you can say, connection that you need to create. So first of all, I will write this thing SQL database agent. Perfect. And I can just close this and let me just write it here. Wow. Let's wait for it. Okay, so this is done. So now what we will do, we'll simply create an agent which will run the query as well, because there are two types of agents. One is like who creates the query. The second one is who just runs the query as well, because we want to create the runs the query as well, because we do not need to just generate the query. Okay, so let's first of all create the database, and we have a special function called SQL database, which is this one, and we do not need to even create cursor or basically the connection. So everything will be done by Langchain. So how we can just create the database connection? If you read the documentation, you will feel a little bit confused, but do not worry, you do not need to create this connection at all. You simply need to use this particular thing, SQL database, and that's it, because you already have the engine. Okay, makes sense. So you simply need to say SQL database like this, SQL database, or let's say DB, whatever you want to say. Let's say SQL DB equals SQL database from URI, and then you simply need to pass the URL, and the URL is like this, SQLite, and we do not have this thing dot, and we have, I think, sales DB. Perfect. And within that we have sales DB basically. I think so, yes. Sales DB and sales.db, I think it makes sense, because we have like same folder within the same, you can say, folder, and then we have the database within that. Okay, so this is our DB that we have created. So far we are good. This thing is done. Now we need to create LLM. Let's quickly create the LLM. Now let's quickly create the LLM, and let me just bring that particular thing, that code, this one. Let me just write it here. So it will create the LLM for us, LLM Openai. So now we have both the things, yes, LLM and DB. And now we need to create a toolkit like this. Okay, makes sense. Now we just need to create the toolkit like this. Let me just copy it and let me just paste it here. So now what are we trying to do? We are creating a toolkit, and in this toolkit we have so many tools related to SQL. Really, yeah, they have built-in toolkit where they have integrated so many tools within the same toolkit. Let me just show you. If you scroll down, if you just write get tools, you will see the entire list of tools. Wow. We have query SQL database, we have info SQL database, we have list SQL database, we have query SQL checker. So these are the built-in functions that are created by Langchain. You can even create your own function. It's not a big deal. What will happen? You will simply get the, you can say, input, then you will pass the database as context, and then you will simply get the query in return, and then you will just run it on Sandbox. So it's not very something magical. It's just like building a wrapper and making your life easy. You can simply use the functions. Makes sense. So toolkit is like toolkit, SQL database, and DB equals to DB, which is not DB, SQL DB, and LLM is LLM Openai. Perfect. Now it makes sense. Perfect. So now what it will do, it will use this database as the context, and it will use this model, obviously, because just tell me one thing, is anything magical happening here? No. So what is happening here? I will go to LLM with my NLP, with my natural language query, right? I will go to LLM. I will say, hey, generate the SQL query. LLM will say, okay, bro, I will generate the query, but at least tell me the database name, at least tell me the table name, at least tell me the column names, only then I can create the query. Simple. So you are going to LLM with this database as the context. So when you pass the database as the context, now LLM has the, you can say, context of the entire database. It knows the database name, it knows the columns, it knows the table name, everything. Oh, okay. So that's how it generates a query. You're simply passing the context and that's it. Okay, so let's run this. Toolkit is ready. And if I just show you toolkit dot get tools, you will see all of the 4 tools that you have. Perfect. Now, We have toolkit as well, we have everything as well. So now how we can just create the agent? So now just skip everything. You simply need to copy this and just paste it here. So we are using langchain.agents import create agent. Okay, so now this is the function that we use, and we use only and only LLM and toolkit. And do we have toolkit? Yeah, we have toolkit variable, and I need to use LLM Openai. Perfect. So now this is my agent. This is my agent. See, now it has created this agent. Model, tools, and blah, blah, blah. And this tools has all the SQL tools. Make sense? Make sense? Now, do you know what? Now you can literally invoke this agent and you will get the answer. Okay, let's see. Ansh, Lamba, let's see. Okay, I will say agent dot invoke. Okay, and I want to say how much sales we made for smartphone. I know the answer. The answer is, if I see the terminal, if I have the real records, for smartphone we made 500, right? What is this 500 and 1000? What are these two columns? Let me just check the init.py. Let me just remove this. So we have price and total. Okay. Oh, okay. Price and total. Oh, because we have quantity as well. So total price is 1000. Okay. 1000. Let's try to use tablet because it is very straightforward. 600. Let's use this tablet. How much total sales we made for tablet? It should be 600. If it is using everything right, if it is using right SQL and everything. Wow, we have an error. Expected dict, how much total sales we made for tablet. Okay. For troubleshooting, this expected dictionary. Okay, so do we need to use any kind of input while calling it? Let me see. Yes. Okay. Okay. We need user and so messages is the key. See, this is the downside when we use the automated created functions. But no, not a big deal. We can just use this one as well. So if you have got the idea, like what I'm trying to say, how much total sales we made for tablet. So we need to pass the messages key as well. Okay, let's now try to run it. Let's see what happens. Okay. Okay. Very good. Very good. Very good. Yes. 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 It is generating the output. Let me just zoom out a little bit. Perfect. Total sales for tablet equals to 600. And it has already given you the reason as well. 3 units into 200 each. Wow, man. Literally amazing. Let me show you what actually happened. So, first of all, I asked this question. How much total sales we made for tablet? Perfect. Okay. Now it made a tool call to this particular function. It's called SQL DB list tables. We didn't create this function. We didn't create this tool. Langchain created this tool. So what it does, it simply lists down all the tables that we have. Because currently I just asked query related to single table. Maybe I'm asking a query which needs to join multiple tables. So first of all, it will list all the tables and it will give to LLM. Simple. See, list tables are done. Then it figured out that I want to use orders table. LLM is smart enough to identify. Perfect. Now this table information. See, SQL DB schema. That means what is the schema of the orders? Like what are the column names? Oh, so this function actually acted and it gave it the schema name, like all the column name. Then this is the table. Create table orders ID integer and blah, blah, blah. This is the tool message. And this is the schema that we pass to LLM. Now AI is smart enough to just generate a query and run the generated query against it based on the schema. Based on the schema. That is why in the modern applications, we always say that whenever you're creating a table, whenever you're generating the tables, you need to provide some description to each column so that LLM can easily pick the right columns. People are saying LLMs are hallucinating, LLMs are not generating right results because data governance is poor. Data quality is poor. You need to create tables with right descriptions. In the modern tools and technologies, there are some options where we can just generate the descriptions like this. And it is important because see, I know that there will be some column, let's say total. So it aligned that particular question with that particular column name. But sometimes we are asking a question which is not very much aligned with the column name. So how it will find it? Using description. Make sense? That's how it works. So see, you have actually built a kind of agent that can create, or basically, and I can also remove it, that can actually write, or basically not just write, you have actually built an agent which can just do anything on your database. Anything. Make sense? Make sense? Make sense? So that's how you just do all of these things. Wow. Literally wow. So it is a kind of agent in itself. Okay. So now let's try to understand the concept of RAG, and then I will just provide you the best resource for that as well. So first of all, let me just provide you that. Then we can just jump on that topic. Let me just say RAG Ansh Lamba. Just search it, and this is the RAG full course that you can just watch. And this is an amazing beginner friendly, like this will not expect anything from you in terms of RAG. And this is, I think, 3.5 hours course. You can simply go there and you will love this course. This is like from 0 to pro, and actually mean it. This is like amazing course. Okay. But yes, let's cover like what exactly the RAG is, just fundamentals, and then you can simply go to this course. Make sense? Because see, I could have just added RAG in this particular course as well. Not a big deal for me. But I know the depth, the fundamental knowledge, the conceptual knowledge, the coding knowledge, the practical knowledge, the implementation knowledge that you will get in this particular 3.5 hours course. Like obviously it is worth watching this course. So I was like, let's guide this particular thing and let's provide this amazing masterpiece that we have created to my lovely data fam. Okay. But still, let me just tell you what exactly the RAG is, why RAG is so popular. Let's try to cover RAG. Now, RAG actually solves a problem. Okay. What problem? So let's say you have this thing. Okay. Well, let's even remove this thing. Let's say you just have that LLM. Perfect. Let's bring it here. Okay, perfect. So let's say you just have this thing, LLM, and you are here. Perfect. Now, this LLM doesn't have the access to your data that we already know and that we have validated as well. Let's say you want to ask some questions from a PDF. And that PDF is actually the sales file for your organization. Okay, simple. Now just tell me one thing. If I want to ask some questions related to that PDF, it can be a PDF, it can be a text file, it can be literally anything. It can be a database as well. Okay, because RAG is not just a tool or just a kind of function. RAG is a concept. RAG means, first of all, retrieval augmented generation. Retrieval augmented generation. This is RAG. Okay. Now what happens when LLM doesn't have the access to your data? How it will access your data? The answer is cannot access the data. That is why what we do, we provide a kind of inventory. Inventory. We provide a kind of folder, we provide a kind of repository from where LLM can access the data. Okay. So let's suppose I wrote this question. How much sales we made? LLM doesn't know this. Let's say you are writing this question from your organization, right? But LLM doesn't know this thing at all. Okay. So now how LLM would know this? So what I will do, I will attach something called as, let's say, a tool. Let's say this thing. Let's say I provide this particular archive or let's say my data. Okay, I have provided this. So what I will do, I will simply link these both two things like this. So now what will happen whenever I will be just asking this question, how much sales you made, or any question, and I know that information is available within this data, LLM can do that. Okay. Is this magic? No. There's a, you can say, logic plus formulas behind it. So what it does, RAG is basically like multi-steps process. That's why I'm just suggesting you just watch that video. Okay. But still, I'm just simply giving you very high level knowledge, very high level. So what it does, it stores your data in the form of vectors. Okay. In the form of vectors. Okay. Let's see if we have anything for vectors. Oh, let's use this one. Yeah, that makes sense. Perfect. This will store your data in the form of vectors. Okay, let's say vector 1, vector 2, vector 3. Vector 1, vector 2, and vector 3. Let's say this has 3 vectors because it totally depends upon that context size that we want to pick, right? So it has these 3 things. Okay, under the hood. So now what will happen? This LLM will go here. LLM will actually go to this thing. So when it is going to my data, actually it is going to this particular thing. Make sense? So I can change the angle now. So this is the reality of it. Okay, so it is actually talking to this. So what it does, it will convert your question as well in the form of vector. Okay. Interesting. And it is called query vector because this is the query, right? Now this query will go. Now this query will go inside this particular area and it will find the relevant vector. So this goes inside this, let's say this, and it found that this query is similar, or let's say it stays out, but it can just go and check that this particular thing is similar. How does it know this? Because LLM knows it through the formula that it uses. And what kind of formula it uses? It uses something called as cosine similarity. It can be Euclidean distance as well, but do not worry, we are not teaching you statistics. Okay, so don't worry at all. So we can just use this thing. So it is not allowing me to just push this. Let me just push it. Wait, because I want to go to this vector at anyhow. Perfect. Bro. Okay, let's do it like this. Okay, perfect. So let's say this query is actually similar to this vector 1. Okay, do you know what it will do? It will return this vector 1 like this back to the LLM. Okay, now what will happen? This LLM has this information in the form of vector. Okay, and then obviously the original text as well. Let's say it has the file associated with it. Let's say any file. Let's say this is the file associated. Let's say this CSV or this TXT, any file. Okay, this file basically data, textual data, because actual data is in the form of text, right? So this will go to this particular LLM. How? On the basis of similarity. And what formula are we using for similarity? You do not need to know this for now, right? Like how it is just comparing this query with this vector, how it knows like it is similar to this and not similar to this and this. Basically we achieve this using cosine similarity or Euclidean distance, but you do not need to worry about that. Just imagine that LLM is doing that, all of that stuff for you, like all the similarity search, right? Okay. And in Langchain as well, we have like dedicated function called similarity search. So we do not need to actually create that function because every, you can say, vector database has its own particular way to retrieve or basically compare the data. So we can just use Langchain's package, simple. So when we have this information available, now just tell me one thing, can Langchain answer, or basically can LLM answer this question? Obviously yes, because it will use this data, right? Now it will answer you back with the with the right answer basically. Okay, perfect. Let's say right answer. Makes sense? That's the concept of RAG. Now, why do we call it as retrieval augmented generation? First of all, retrieval. It retrieves the similar vector. Then augmented. Augmented means making something enriched, making something curated. So we augmented our model with this particular text, which was not available to LLM before. And at the end, we generated the data with this context. This is called retrieval augmented generation. This is the high level overview, or you can say high level process of RAG, complete process. Now, how to store this data, how these vectors are created, how the similarity search is happening, how this augmentation is happening, how generation is happening. You can watch that video that I have created on this channel, and you can even search it on YouTube, RAG Ansh Lamba. Okay. Or I will also attach the video in the description. If not, you can simply search on YouTube Ansh Lamba RAG and you will find that video. I would say that's all for this particular video, and I know you learned a lot of things and you loved this video. So just hit the subscribe button right now and just click on the video coming on the screen, and I will see you there. Bye bye.